Okay. So everyone can see this okay, I presume? Everybody's good?
Yeah.
Being able to see. Okay, great. Well, first of all, welcome back, and my sincere apologies for the late start here this morning, but anybody think of any questions in the interim that we can go over? We might need.
Yeah. There are a couple of questions that were brought forward. I think
Okay,
I'll just pass you to Jerry. He could ask the questions he had, and
all right.
then also he has an issue with his Carlson, but maybe you could answer that as well.
Okay, great.
Jerry. Great. Percival.
Yeah, first, if Jerry was speaking, let's say I've got the computer that says Jerry Banks shows as being muted. I've got another Jerry though that says okay, but I did not hear anything.
Oh, hello,
Yes.
Percy.
Oh, Percy.
Morning, Ken. Yeah, we're here. I'm actually discussing the issue with my coworker.
Okay.
Maybe as we wait for Jerry, anybody in the room who has any question for him? Ujo? No. Percy.
There we go. Now we're doing recording. So anyway, if you recalled on Tuesday, we were finishing up some field to finish examples to come up with, this little site survey that we had just based on our point descriptions. But there's another approach, another way of using field to finish that I wanted to show you real quick to wrap this section up. And it's shown there on page 70 of the user's manual. What's called doing field to finish on the fly, as you might run into it from time to time. So we're going to start a new drawing file, and we're going to use the coordinate file called mantopo.crd. And we're going to draw that into our drawings and take a look at the points and then see what that is going to uh, generate for us real quickly. So I'm going to load up Carlson. And again, we will start a new drawing file. Finish this loading here. And it doesn't matter at all what drawing template we use, just we're going to basically have an empty drawing. We're going to set in some points. So I'm going to set my folder. I'm now looking at Carlson projects. I'm going to look at my 222 survey class and my data sets. Thank you. Gentlemen, never underestimate a good lady. She brought me a lovely cup of tea, fixed just the way I like it. So that's a nice way to get started. All right. So in our data sets folder, I'm going to create this one as field to finish on the fly. Example. And I'll just leave everything exactly like that and choose next. And I will have an existing coordinate file this time with no import. And I'm going to set that existing coordinate file to we're looking for this one here called mantopo.crd, which is right here. And I see over in my little data preview window, it's got points 1 to 356. That's the one I want. And I'll say next. And then I'm going to locate my points. I'm going to change to different symbol there just to be slightly different. Make sure I've got my descriptions and elevations and real Z's and all that done. I'm just going to say draw all. And very shortly you will see a list of points that have come into my drawing. Again, this is all I have. I'm going to take a look at those things just to make sure I can understand what they look like on the ground. So I'm going to go to my view menu, my 3D views, and my drawing viewer, which is the one that lets me look at things in my drawing, as opposed to my surface file viewer, which lets me look at surface files once they're made. So if I look at this and spin it up and around, and I can see that, yeah, there's some points there, and there's some that are, looks like they're relatively smoothly across the top. Excuse me. And then I've got some points out here along these edges. And you can see, like, looking down this edge here. In fact, if I give it a little bit more of exaggeration, you can see that you can see that edge show up. Okay, so if we wind up using this information to generate a surface for us, where their normal steps would be. And there's one general thing would be to simply draw a shrink wrap entities. We could draw a boundary around there, although there are no in-cutting areas, so we don't even really need it because everything is convex all the way around the edges, except for a wee little thing right in here, but that's going to be sufficient. So I'm just going to run a quick surface. So I'm going to go to the surface menu, triangulate and contour. And I'm going to write the triangulation file. I will say set or select rather. And in that surface, I'm gonna call this one, man topo dash EG. And I'll go to my contours tab. I will draw those contours. The contour interval I want is for 1. I'm going to draw index contours. I'll make that 5. And
Excuse me, do you want us to follow along?
yes, if you could.
All right, then slow down a little bit then.
All right. You need me to go back to the start?
No, go back to
Okay.
the triangulate tab so we can see what you had for triangulate.
Oh, okay. So if I triangulate, I'm just going to write that file and I give it a file name. And excuse me, since I did not actually draw the shrink wrap around the data this time, I did not draw it out here manually. So I'm going to uncheck that box, but my shrink wrap reduction, I'm just going to say, let's use none because I don't see any import, any inset areas to try to filter out. So I'm going to say, if I said low, for instance, and choose this setup button, that's going to let me change this. I'm going to draw the perimeter on let's just call it BDY for boundary. And then I'm going to switch that back to none, but I did want to set it to low so that I could choose the setup to have it draw and the way I wanted it to draw. Then I'll just set it back to none so that it does that without doing any reduction. And let's see what else. I don't have any break lines, so I'm going to not need to do this densify break lines. It won't hurt to leave it on, but there's no need for that. Okay. Now switching to the contour tab, just so we can see the contours here, we will turn them on and we're going to draw the contour by interval. And then over on the right, we're going to say to draw the index contours. And then the contour interval I want is 1, and the index interval is 5. Doesn't matter at all what layer you draw these on because it'll create whatever is called for, and it will make them the color that it'll make them red and white, I believe. At the first pass. And you can always change that layer definition later if we need. Well, let's go with that. And I'm going to uncheck everything here in the top section of check boxes. And I'm going to say no smoothing. I will next go to my labels tab and I will just label that if you want. And I'm going to set my label to the check boxes that I'm going to use is to hide the drawing under the labels, label the index contours only, align the text with the contours, draw on the real Z axis, and then I'm going to go for a distance interval. Just going to say every 250 feet. At 600 and some is a little bit too far apart. And then I'm just going to check over here on my selection tab just to make sure I don't have any filters going that might limit out what I'm choosing. So I'm in good shape there. And now I can say, okay. Now reading the prompts, remember we did not say use inclusion and exclusion boundaries. So it's not asking us for that. It says select entities. We read the line above and says, select the points and the break lines you want to triangulate. Well, that's just basically all your data. So I'm going to draw a window around that and finish selecting. I'm going to hit enter. and you're going to see a resulting set of contour lines. And they look, fairly what we might expect up here on the top, but look at this jumbled mess down here below. Okay. And if we, I mean, on the edges, and if we should happen to, just want to take a look at that, what it looks like in 3D, you can see, and all I'm doing, I'm not looking at the surface exactly with this. I'm looking at just the drawn contours and the points, and you can see how these are sort of kind of real moonscape looking, jumbly, all not necessarily very well representative of what we saw before when we were looking at just the points. Okay. And we can do that also if we go to view, 3D view, surface file viewer, and we find our man topo EG. And now you're going to see basically that same thing, but with the surface filled in, and you can see it's really sort of, jumbly looking over here on these edges. Okay. If we wanted to have it show us where the contours are, we can go to our settings tab and choose display contours and set the interval there. And again, this is just done in memory. But as you can see, there are some issues out here on these edges, what are supposed to be ditches along the edges. So to be able to have field to finish help us here, if we come back in with something like this that was not set up correctly with the drawn elements, there's a couple of things we can do. I'm going to go to the edit menu and erase. I'm going to erase by layer because I want to get rid of those contour lines so we can start looking at this. So I'm going to hit the clear button. If there's anything in this list here, I will select layers from the screen, and I'm going to select one of the labels, one of the index contours, and one of the intermediate contours. Hit enter, and I see those are the two layers. That's where my contours all went. I'll say all to erase all things on those layers and say okay. So now I'm left with the points. But let's start looking over here along the edges and see if we can identify something from what we, what we're looking at here. So I've got a bunch of points that say ground shot, ground shot, ground shot, ground shot. Okay, so those look like they are just shots on the ground. Much like in our example yesterday from your data where all of those descriptions said G, okay? But the field crew in this example also created some points with some descriptions here that say 17, 18, 18, and 17 going across this what turned out to be a real jumbled looking mess. So I've got 17, 18, 18, 17. I come over here, I've got another 17, 18, 18, 17. I look over on the other side and I see 17, 18, 18, 17. So what might that look like? Here's a 17, 18, 18, 17. If I wanted to see that, to look at what that might look like. And one quick way to do that without bringing it up in the 3D viewer is I can go to my surface menu and go down to this bottom section where it says quick profile. And I'm going to choose that quick profile. And it wants to know the source of my surface model. I'm going to change that to screen entities instead of the surface file. So I just want to be able to look at these points right here to see what that might look like. I'm going to say okay. And it wants me to pick a starting point. So I'm going to come down to my settings menu. I'm going to turn my point object snapping on. And I'm going to go over here to this one thing called ground shot. And then I'm going to pick number 17, or this one with the description of 17. And then one with 18, with 18, with 17. And then finally, let's go back to this other ground shot here as well. I hit enter when I'm finished that and it didn't show me. Well, great. All right, so let's do it another approach. Let's draw the line so we can choose the line. If I go to the draw menu and choose 3D polyline, let's do that and choose okay, pick a point or point number. So I'm going to go to that 166, 149, 106 to 63 to 20 to 248. Okay, so I now have that as a 3D polyline. I'll go back to my survey or surface menu and choose quick profile, change my source to a 3D polyline. And then I'll pick that 3D polyline that we just drew. And now you can see as I go back and forth, I started out here on the eastern edge. I went down to the first point. This is 17. And then I went up to a point that says 18, then 18. Then I've got another 17 up here. And then I've got a ground shot up here. Okay, so I've got this type of scenario. I've got let's see what happened. I've got this, if I look up here, I've got this point at 166 that has that elevation of 1177. But I'm looking at this next point, this 17, or the point number 149, which should be at 18.001. But it's at 0, and I can look at that and tell it's because I missed that point. So I'm going to exit this, and I'm going to go back to this 3D line, and I'm going to fix that so it grabs that point. So I'm going to just select that line. I'm going to grab that grip, and I'm going to snap it right onto that point. And so now you can see I've raised that back up from where it was down at 0. Hopefully you did not miss the point when you did yours. So now back to surface menu, quick profile by 3D polyline. And now when I choose this, that's really what I was looking for. So I've got my starting point out here on the east. And you can see in the profile down below where the crosshairs are. That's over there on the ground. And then I get to what I've expected to see, this feature that looks like a ditch. And so it looks to me like that point 17, or I'm sorry, point number 149, which has a description of 17. That's up here. It looks like that's on the top of that ditch bank. And then I come down here to the 18s. And I've got points along the bottom of that. And then I come back up here to a 17. Then I've got a ground shot over here. So that's what I was expecting to see. However, if I, were to look at that again in a quick profile, I'm going to switch it to a surface file this time and choose the first button and choose that man topo. And I'm going to say down here in my prompt, instead of picking a starting point, I'll say P for polyline. And it wants me to select that polyline. It'd be right there. And now that particular one happened to work. But if I adjust this alignment, you can see as I move this along, you can see the ditch stays okay in certain places. And then there are other places where this, I'm trying to find a good example. Looks like they're all sort of working there. Exits. That, let's go back and run that one more time. Quick profile, surface file. We'll say, okay, and I'm just going to draw a single line just straight across. Like there, it'd be a little easier to show. And then if I adjust that alignment, as I move this, you can see that in places it looks like it's modeled it correctly with the ditch. But then I'm going to get in some places, like right here, you see there's no ditch showing, but I know that there's supposed to be one. Come back here and I got some ditch elements are still showing up. I've got some places where the ditch just completely falls out of the picture. Okay, so if I look at that in here, you can see I started to pick that back up with my ditch. So I got a sense of, once I look at this information, that, what should I have done to keep that from happening? If you recall, when we were doing these edges, we really need to put break lines in all along the top of the ditch that connect up all of the tops of ditches and then all of the bottoms of ditches. And so, again, we could go through and connect the dots with all of these different codes, connecting 17s to 17s to 17s and going back and double checking. Now we got a little bit of a mess out in here, but I also see a couple of things that are going on with these descriptions. If I look at this particular point, now I'm going to go to my points menu and I'm going to say move point attributes with leader so I can unclutter some of this stuff. So I'm going to bring that one out. Let's put this one over here. This one out. Here, this one out. Let's pull this guy back and then this guy out and this guy out. Okay, so let me go ahead and get this guy out of the way too. Here is how we can interpret this to look. I notice I've got some of those extra codes here. I've got this 18 BEG to begin. I see up here I've got a 17 end, and that's point number 52. So I might think that I've got, potentially some other 17s that are coming into display. And it looks to me like our surveyor went out there and he coded this up pretty well, pretty correctly. He's using a code 17 to indicate the top of bank and the code 18 to indicate his bottom of bank. And he's got begins, he's got ends, and it looks like they're done sort of numerically in order 50 to 51 to 52. And he's got one here that says, here's a point on the bottom or the top of the bank. But I also want to join to point number 158, which is over here. So 10 joins to 158, which has been, if you look at my 17s coming this way, 156, 157, 158 ends. And he's just putting a little cap along that line from 17, joining it up to this particular point. Okay, and we'll see what's going to happen with this in a minute. So if I go back to my points menu, and I'm going to move point attributes with leader, but this time I'm going to restore. Let's see if I can. I guess I'd have to do that. Hit an R to restore. Which of course you don't need to do. But if you just want to clear up those leaders, you can reset those back. And so now we've got a sense that we've got 17s are going to be our top of bank, our 18s are going to be our bottom of the bank. And we see that we've got, looks like 18s, 19, 20, 21, looks like they were done. I'm going to verify also under my points menu, list points. I just list them all and I'm going to say, okay. And I see that I've got some point number 10. And it's going to join to point number 158 once it finds 158. And then at 11, it's going to begin this point and go from 11 to 12 to 13 to 14 to 15. Those are all my 17s. They are in order. I've got an end, which is going to join to point number 11. Actually, I think that 158. Yeah, so 11. And then it's going to begin point number 53 as an 18 code and go all the way down. And then it picks up another 17 begin. So it's finished one of them and it's going to start on a new one. Looks like, and then we're going to end. And then I've got all those ground shots in between. So it looks like they did this in a way that we can take advantage using field to finish, knowing that we can set the codes to try to draw those. Now, you know, could we manually draw these few break lines in? Sure, that's not hard to do. But assuming that there's some other kind of process going on and you've got the points are coded as if they should have been done that way, but we don't know what those codes were. Maybe we got this in from a crew that used the wrong descriptions one day, or from, you know, some private surveying company that didn't give you any kind of a code table that you can use. So as we can use field to finish, like we called yesterday, we can go back to survey and choose draw field to finish. And this time we're going to, I'm going to say all points. And I'm going to come down here to the bottom where it says my code table. And this is where I'm going to choose set, and I'm going to make a new one. And I'm going to put that in my working folder here, not in my settings file, which is where it wants to start looking for it. And I'm going to use this new code, this new table, and I'm going to call it, F2F. On the fly. And we'll say open. And now, because it's a new one, it's going to give me some tools to get started. I could either make a code table by points, I can import codes, I can do all of these different things, but the one I want is to make a code table based on my points. So I'm going to choose that. It has now made it, and I'm going to edit my codes just to see what the behavior is. And I've got 3 codes it found. I've got 17s, 18s, and ground. Now, if you recall, some of those points said ground/shot. But what does that mean? It means the slash character, if you remember, is a special code. So I look down here on my left-hand set of buttons and I look at those special codes just to get a sense, to remind myself, there's this slash character right here in the upper left, 4th down, that says to append the description. So it's going to take everything after the slash. In the case of that, it's just going to say shot and put it on whatever the description that the code, the main code back here, which is ground, if that ground code says to use a particular description, then the /shot says add that word shot onto the end of that description. All right, so okay, I noticed that one, and I also noticed some others. I had some BEGs, I had some ENDs, and I had some JPNs, and that is simply a code to begin the line work, to end the line work, and also to join to a point number. Okay, so I'm good to go with those special codes. I've figured out what's going on. That simply leaves me with the 3 codes. So I know that I don't want to do anything with this ground code as far as drawing lines go, but I will hit the edit button and I'm going to change this behavior for this code for just this particular one use. And the main layer that I'm going to put the point on would be, instead of ground, let's just call it, spot. Let's see. Spot height, okay, which is what you would use on yours, in your example. So it's going to create a layer called spot height, and it's going to put all of the things that say ground on that layer. I'm also going to go into the description field. I'm just going to clear that out because I don't need it to say anything about ground, but it will read the /shot, and so it will type in shot to go along with each of those points. And let's see, I'm going to make my attribute layout ID. I'm going to change that to 2 just because I like them lined up instead of the default of 1, which centers the point number over the point, the elevation to the side, the description underneath. I'm going to change that one just to see how that behaves slightly differently. Okay. For the symbol, I'm going to use the symbol tab. I'm going to go over there and choose that X symbol. I'll go back to my general tab, and down at the bottom, I'm going to make sure that I say points only. And I'll say, okay. All right, so I'm happy with that one. Now I simply need to have all of the 17s create some break lines and the 18s to create some break lines. So I'm going to edit those individually. 17, 17. I'm going to say, I don't need any descriptions. I might write in the full name just to tell me what it is if I want it. No descriptions. The main layer, I'm going to put this on a layer called top bank. And I'm going to make down here below, instead of points only, I'm going to say a 3D polyline. I'm going to have it draw a 3D polyline. And I'm going to set its color to be this magenta just to help me see things when I'm done later. I'm going to go to the symbol tab now, and on the points menu, I'm going to make sure it is turned off with nothing selected, which should be okay because I said just draw the 3D polyline. But just to verify, there it is. My line type, I want it to be by layer because it's just going to be a 3D line. That's fine. And I'll say okay. I'm going to do the same thing for code 18. Again, I'll take that off. In my description, I'm going to call that
Ken,
yes, sir.
sorry, there's something I forgot to ask you to just explain to us.
Okay.
In terms of us collecting this data for the points that are there on the screen, we actually have to do sometimes a traverse or do some checks on our points. Is
Right.
it possible to compute a traverse with Carlson as well as do an online check and an area computation check?
Oh, sure.
Could you maybe show us that maybe when you're done with this? Maybe it would be
Yes,
good for the to know as well.
yes, absolutely. So when you're doing traversing, like to do, you can actually balance the traverse and
Yes,
yes. Yeah, so
okay.
yeah. So that's
So
not
you will-
yeah, that's called our raw file processing. So we'll come into that as a real quick example of the next thing to do. So all
And
right.
could also maybe check as well how to compute bearing and distance as well between 2 points.
Oh, yes. That's part of our
Oh.
code. We actually did some of that the first day with the invoicing, but we'll go over it again just to reinforce it because that's the typical thing
Okay,
you guys are doing. All right. So
thanks.
yes, absolutely. So now on the I'm going to set that layer name to be, let's see, I'm going to be a 3D polyline, BTM, bottom bank. And I'm going to set its color to be yellow. Okay, just so we can see those. So I should expect to see this line work come in connecting 17s to 17s, 18s to 18s, and the ground shot elevations are just going to be by themselves. Again, I'm going to set my point attribute layout ID to 2. That's just a cosmetic thing, makes no difference whatsoever. So now I've created these. I've found my codes. I'm going to use that to help me draw the break lines so I don't have to play connect the dots on all this data. I'll now come down here to the save button to save the code. I will now exit and then I will hit the OK button and I'm going to let it redraw. And now I see all of my 17s, which is point number 26, you see is a 17, but it doesn't have, and I just double clicked that point, number 26. Shows you where the point is. There's no symbol. There's no description because my field to finish said don't draw those. However, that you see it does still have a code in the CRD table. It has a description of 17, but on the screen, it doesn't have a description and there's no symbol. Same thing for these points along this yellow line, like 111 and 68. If I do that, I can see, I mean, if I double click that one, I can see that it still has that CRD file code of 18. There's no code in the drawing. There's no symbol, but I did draw the lines. I used it to now help me create these as break lines. And the way these break lines are going to work, if you remember from the last jumbled up surface we had, we got that because some of these points, like this number 180 that you see on the left, might have formed a triangle going across, say, straight across to 238. So it says in that particular spot, it's filling in the ditch, and really it needs to come down to the yellow, over to the yellow, and back to the purple, and then over to this way when it builds those triangles. But we didn't have any of those break lines drawn in there to keep 0.180 from seeing 0.238. Okay. These down here were probably close enough that, you know, these two particular points, 133 and 122, they're probably close enough that, you know, right in that vicinity, it defined the ditch and the triangle edges formed correctly. But if you get in between, where sometimes these triangle edges can look across empty space and find these other points. And so that's why we needed to have those edges drawn as break lines. And again, if I view my data, well, now I've got a real good, clear indication of what that should look like. I've got, you know, a nice, relatively broad ditch here, not too deep, long, laid back slope on one side. The other side, I've got a similar situation, and it goes all the way around the back corner. Okay, so my tops of banks, my bottoms of banks. Now I've got a little bit of a crossover right in there. And that might have just simply been, it looks like it was just simply due to the angle I was looking at it, because now I see they don't cross. So that should be fine. So let's go back and recreate this surface model and see the difference. So if I go back to my surface menu, triangulate and contour. Now, the only thing I'm going to do differently here is where it says write the triangulation file, I'm going to hit the select button, and I'll choose that same name just to get started, but I'm going to put, you know, a dash mod or -2, something that's just going to make a difference in that particular surface. I'll say save. And I will also, because now I have break lines, I'm going to densify those break lines every 10 feet just to help smooth things out. So if I've got a long distance between, it's going to artificially, inside the computer in memory, it's going to put in extra vertices along those break lines to help, you know, create, or to help eliminate making these very large triangles. It's going to smooth them out to be a little more even. So that's the only change I'm going to make. I'm going to say, okay. And again, it's asking me to select entities. I read the line above it. It says select the points and break lines to triangulate. Again, I'm just going back and grabbing everything. I select it. I'll hit enter, wait for it to process. And now when I see those contour lines, I no longer see that jumbled up mess that we saw before. And in fact, you know, we could at this point, you know, freeze off some of those points, We don't need them. We're just gonna verify real quickly in our viewer how things look. Well, it didn't work. That's why I wanted to verify this. Notice what happened there. See how those contours jumped right over those ditches? That's not what I wanted, is it? So let's see if we can figure out that. It looks like the contours worked okay on the tops. I think I know what happened. Maybe. Let's see. That is a 3D. All right, so also to verify that, if I look at my surface itself, even though it did get the slope, it didn't find the ditch. Okay, so it's missing those points. And let me see if we can find that out. If I look at this 0.130, don't not sure why that's doing it. I have a suspicion it is by turning that point symbol off. I might have done it. Let me take a look at that. Let's go back to draw field to finish. So survey, draw field to finish. I'm going to edit those codes again, and I'm going to look at my 0.17, my code 17. It is drawing a 3D polyline. And it's located points on the real Z. I did say no point symbol, so let me change that. Let's see if this makes a difference. If I use a little tick mark. Same thing for 18, it's a 3D poly. Ah, okay, so it wasn't the symbol. I'll show you what has happened here. I'm going to go to the symbol and I'm going to leave that symbol off. I didn't want to show the symbol. But notice here, if I look at 17, notice down below here, I said, locate the points on the real Z axis. I'm drawing a 3D polyline. That's what I intended, okay? Look at 18. I accidentally, down here at the bottom, underneath, locate points on the Z axis. What did I say? I said non-surface. So it ignored all of those tops of banks codes or bottom of bank codes at 18, which was my bottom of bank. It ignored them all because I said it's non-surface, so don't use the point to create the surface. That was an accident. When I was doing this real quickly, I accidentally double clutched right in there and sort of turned that on and didn't catch it. So I'll say, okay, now now that I've unchecked it, I will save, I'll exit. I'll say, okay. It's going to recreate the line work. And now when I make my surface, triangulate and contour, remember I've said to erase previous contours is already set. I don't need to do a thing other than hit the OK button and say yes to overwrite. It cleared out those old contours. Selecting entities, I can just type the word all, hit enter, hit enter. And now I see the contours looking like I expected them to look. And if I look at that here, you can see those nicely defined contours through the ditches instead of that old jumbled up mess. If I go to my model tab and under surface, if I right click and choose add a surface, I'm going to add that new surface that we just created for the second time. And you can see how that surface follows the tops and bottoms of the bank. Now, probably around this little corner, we could have made that a little smoother than, you know, we could add a few extra points in there to smooth that out. If that's what's really going on out there, we don't know, but just as a much nicer means of creating a valid surface around these edges, that what was important to have were those 3D break lines, the top of the bank and the bottom of the bank, which you could at, you know, at some point freeze those off and you can see you just got the resulting contours now that you've taken steps to make sure that those contours don't wind up crossing where they're not supposed to cross. Okay. So that's just a way of using a very short little coordinate file. It's only got 3 different descriptions in it. As long as, you know, the tops of banks were coded separately from the bottom of the bank and the random shots. Now, if all of this stuff had been done, everything along the top of the bank and the bottom of the bank and out here, if they were all done with a description that just said G or, you know, SH for spot height, if all of that was done like that, then with all one single code, then we could not have used this technique to have done it. So when we're out in the field collecting the data, think about this in terms of how field to finish might be able to come into play once you bring that back into the office. It might can help you generate your results pretty quickly. Okay. So with that, we can close that out and let's go on to the next business here with this raw file processing. And I'm going to come back up here at my table of contents and see if I can find that. This it's on page 59 of the module. It sort of starts out what we're doing with our raw file and how we use that to edit some traverse information and to calculate closures, and also to, as we generate coordinate geometry commands in our drawing, we can actually use that to keep track of things as well. So let's go through that as a couple of examples. I'll leave this to your own reading. On page 59, right here's a perfect example of why do we adjust our measurements. I was teaching a class in, somewhere in the South, I think it was either Mississippi or Alabama in that part of the country. Doesn't matter where it was, but we were going over this idea about using adjusted measurements, and the owner of the company was there, and he said, it was a young fella, and he said, we don't bother adjusting our observations because our instruments are in, we keep them in good adjustment. We know that the instruments are nice and accurate. And so if somebody's bringing information in from the field that needs to be adjusted, then they've missed something in their technique. So I would send them back out to the field to re-observe that data instead. So he's saying, I'm going to trust the instruments to be exactly right. And so if there's a problem, it's because they did something wrong in the field and he goes out to do it. But really what happens, and here's where we talk about that. This is especially with GPS equipment and high precision measurements, we're tempted to just let things go and they're going to be close enough, we might think. Okay, but it's true, but what does that do? If we do that, if we accept those raw computed positions, then you're going to still have some problems because there are some sort of systematic errors in setting our instrument up over a point and pointing to the target. All of those things are going to have some fairly, standard types of missed locations. Just you get your crosshairs off just a wee bit, or you're not sitting exactly perfectly plumb over a setup station. There's all these little bitty errors that are going to tend to go through. Now, as you're doing your work, those things will sort of average out. They'll cancel each other out. That's what we call these systematic errors. And so, we extend that these errors will tend to cancel each other out. So we think of averaging across the system. But here's what the results of not doing our adjustments is going to have. So if we do not adjust the measurements, you're not averaging or distributing that small accumulation of errors to all the measurements. And so what happens is that you're going to basically throw out the last measurement, because as you've accumulated those errors as you go along your traverse, but you're saying, I don't want to account for those. I'm just going to let those errors, keep adding up and subtracting and subtracting. I get to that last error. And so if I were to try to fix that, I'm now trying to close that last observation back into my control, and it's going to be slightly off. And so if I just accept all of the raw measurements, I'm saying I'm still going to wind up taking all of those little corrections that I should have made throughout the system, and I'm putting all of the correction in that final last measurement. Okay. And so like so this places all of the correction in that last measurement. And like I said, that's a little bit unfair to that last measurement because it was probably observed just as carefully, if not more carefully, than the ones that happened before. So what we have tried to do then over the years is come up with these means and methods of adjusting those observations. Okay. And we have a couple of things up here. If we're doing traverse adjustments, we've got a compass rule, transit rule, Crandall rule, and compass rules adjustments are pretty much our preferred choice with modern equipment because it is based on the assumption that the angular measurements are just as precise as the distance measurements. And you can see in contrast, if transits assume that the angles are more precise, whereas Crandall also does that same assumption, but provides a little limited least squares type of an adjustment that provided equal weighting to all the observations and didn't come into the full mathematical rigor of a full least squares adjustment. And that's down here as this statistical measurement that computes a best fit solution based on that when there are excess measurements of certain variables that have to make up the model. And that's going to actually require redundant measurements as you go through. Okay, so what we're going to look at here are a couple of examples We're going to use these raw files, which are the files that are in the data collector, not the coordinate file, but the actual raw file itself where we've measured the observations that record the station setup, the backsite, and then our traverse data and all of our side shot data. And we'll see how we're going to look at those to make these adjustments for us. Okay. And then when we get to the end of that little thing, we're going to show you also how we can use that raw file processing just to do our standard coordinate geometry computations in the office. And that sort of gives us a chance to, keep a paper trail, if you will, an audit of our work. Okay. So let's go to that example. And here's where we're going to start with our procedures. We're going to start a new drawing. We'll give it, just a blank drawing. And we're going to start a new coordinate file to use with it. So it's going to be anything that we want. And then we're going to go to our survey menu and we're going to choose edit process raw data. And we're going to open up this file called rawfile1.rw5. The rw5 is the extension of the raw file. And I'll show you what you would need to do typically on your end from your TopCon, or I'm sorry, your Trimble raw files, okay, if you're using those. So let's go and make our new drawing. And I'm going to choose next, and I'm just going to take my default, which was my Carlson DWT, and finish. Now, once that comes up, it's going to ask a couple of things here. I'll just leave my scale set to 50 scale. Let's see, I need to, up here at the top, I need to give it a drawing name. So I'm going to choose set. I'm going to make sure I'm in my working directory here. And I'm going to call this one raw file example. And choose next. And the next step of that will be to ask me for a coordinate file. And again, I don't have one yet. I will say a new coordinate file. I will accept the offered name of raw file example.crd. Import points. I'm not going to import any points. I don't have anything to import them from yet. So I'm going to say none. And I'm going to say next. Okay, so now just a blank drawing. And we're ready to start processing once we open up the raw file. So let's go to our survey menu and let's choose edit process raw data. And again, this is going to take a raw file that we either create or open. And again, you can create, just add data into this thing, as you will, just like a spreadsheet. It's like another means of, doing some computations, if you will. But we have a raw file that came in from one of our data collectors, and we're going to use that to do our work. But before we open that, what you would typically do on your end is to go to the file menu and you would choose import and you would go to your Trimble choice down here at the bottom. And then it's going to ask you for, if you look up here in the top green stripe, the Trimble raw file to import. And then it says parentheses DC semicolon JXL semicolon. What that means is it can import those two types of files, files that have a .dc extension or a .jxl extension on the file name. Okay. So if you have those from your data collector, you can import them directly. Now, since I don't have any of the Trimble data, I'm just going to go to File, and I'm going to open a raw file, and it's going to use, as it says, save changes to, and I'm going to say no. I'm not going to save any changes. I had an empty file there to begin with. But the raw file that I want to open is this one called raw file 1. And you see it's pretty sparse over here. I've got some that are much larger, and we'll look at those in just a minute. So I'll say open, and I should see something like this. It's like I said, very simple, just for us to get started with it. And there's a couple of things that we're going to note. You should see a split screen. You should see a spreadsheet in the upper half and a graphic display in the bottom half. If you don't see that, it could be just this. And that's because the graphics are turned off for whatever reason. Maybe the last time it was run. And that's one of these buttons here, the one that has a little pencil and the squiggle says to turn the graphics on and off. It can also work from this display menu where you display graphics on or off, whether you want it to be in zoom mode, you want fixed text sizes, or if you want the text to get bigger or smaller as you zoom in and out, that sort of thing. Okay. So all of these, well, not all, but most of these, a lot of these commands, let's change it to that you see on the menus are available in these icons along this top bar. That's just a little toolbar that kind of gives you some faster access to trying to pull this down. But all of this stuff is going to happen in these menus. We can open and save raw files. You can open and save coordinate files right from inside of here. So if you wanted to switch to a different coordinate file, right now our coordinate file is empty. We haven't done any computations to create any points. And you've got also this file menu, open, save, settings. So if I choose that, that doesn't mean that it's going to ask me to go out and open a settings file or to save a settings file. That's not the same thing as you typically see in your dialog boxes. What this is are settings that happen when you open and save a raw file. You can tell it that I want to prompt for a raw file when I start up. So instead, before it was off, you notice it came up and it was blank. I then opened the raw file and it asked if I wanted to save this other thing, which I didn't. Okay, so you can eliminate that, have it ask you for a raw file once it starts, and you can have it down below the other checkbox to save the save settings. You can have it automatically save the coordinate file if you want to. I leave that off. I like to wait and make sure that I know that I'm happy with it, and then I'm going to take the steps to save the coordinate file. It also will, even if that's unchecked, once you do this work and you exit the raw file editor, it's not going to exit it and throw your work away unless you tell it that that's what you want to do. So when you exit, if you haven't saved the coordinate file, it's going to prompt you if you'd like to save it, at which point you can then make that decision. But we have two little codes here that we're talking about, that if we have a closing shot, So we're taking, we're winding up our traverse and we're closing back into our known control. Then we're looking for a description on that particular line of the raw file of the word, whatever you type here. In this case, it's going to be closure. So if I know if I'm sitting, if you look at the picture down here, if I know that I'm sitting at point number 4, I'm backsliding point number 3, and I'm turning the angle around to point number 5, which is really also my point number 1. I know that that's my closure shot, okay? And also for the angle balance, if you have another shot that balance angles, I'm going to call that angle balance. And then in my particular case, in this real simple example, shot number 4 into 5 is going to be both a closure and an angle balance. And that's one of the things that we can set as well. Okay. So that's just some settings that once you've told it this, that's the way it's going to behave until you change it. Okay. Now we've got a couple of other items here. You've got some editing functions. You can delete a row. You can find a certain observation, go to a particular row. You can scale, modify measurements, convert points to note records, convert GPS to note records, et cetera, et cetera. You can edit the coordinate file, which will bring up the actual computed coordinates, which we don't have any yet. And then you've got everything here that controls the display, one of which are these spreadsheet colors. So if you see here, I've got blue lines, black lines, magenta lines, red lines, and green lines, and that's because of these color settings, so that once you're familiar with those, you can look at these and immediately tell what kind of data is on that particular line. Okay. Then on your add menu is where you would actually, if you were coding in, let's say you didn't have a data collector and you just had field books, you had field notes, and you're going to put in the setup and the HI and the HR for your instrument height and your reflector height, and your backside point number, your occupied point number, your angle right, and hopefully you've flopped the scope and you've got more than a single pointing to those particular traverse stations. So you can add all of these different things in there. You can see there's traverse, side shot, backside, instrument height, different, so point, you can put in a blank point, or you can import it from a coordinate file. You've got coordinate geometry commands, so you could enter like a distance intersection to compute a point. You can put those in here as well. You can have a reference azimuth, the control file standard error, the setup standard error, and the measurement standard error. These are your standard error values that you would put in if you were going to do some least squares processing as part of this. And then I've got all of these other commands. Here's where all the work happens under the process menu, which, as you can see in parentheses, the menu itself says process or compute points. And I've got a couple of things. I can do a no adjust. So it's just going to compute based on the raw run through the observations. I can also look at balancing the angles. Let's see how my distances work, in which case, let's say that our angle work was a little bit sloppier than our distance work, then we could, or not, that's the other way around. If our angle work is really pretty precise, but maybe we've measured our distances with a steel tape, then, we could spread the misalignment in the angles through the whole system with this angle balance, and then we can let the rest of the adjustments work on the distances and see how that works for us. And then we have our compass rule, Crandall rule, transit rule, typical traverse adjustment techniques. And then we have this least squares adjustment. Now I'm pointing this out to you here because this is available in Carlson as a single network least squares adjustment. Right, and it's okay in as far as it goes. But I'm going to suggest that you don't want to do your least squares adjustments inside this command, the edit process raw file. It can, but only if it is a single network set of observations. There is another command out here under the survey menu. It doesn't show up for me. But if I pull down the survey menu, there's underneath edit process raw file, there is a least squares. I'm gonna close that here just to show you what that looks like. So edit process raw data, there's level data, and then SDMS data, but there's this one, serve net least squares. And when that command runs, it will process a multi-network least squares. So it takes care of all of the redundancies that you would have in a lot of duplicated measurements. And that's the one that you would use typically for, very rigorous least squares adjustment of large networks and large traverses. And Carlson, it's an interesting little bit of trivia history here. Carlson, when they didn't have any multi-network least squares adjustment algorithms that they had created built into their software yet at one particular point. They looked around the industry and they saw that a lot of surveyors, no matter what software they used in their day-to-day work, a lot of them were buying this little program called StarNet out of the back of magazines, like the back of a POB magazine, the Point of Beginning magazine. And it was a relatively inexpensive piece of software. I think it cost a couple $100. And they, but it was one that was written by two guys named Elgin and Knowles. They were both professors at the University of Arkansas at the time, and so it was very rigorous and mathematically, or mathematically rigorous and exact type of treatment of survey data. And that's what all of these surveyors all across the industry were using, was this thing called StarNet. Well, there was another competing surveying program out there in the world that was similar to Carlson's called C&G. We talked about that on the first day into that setup for the menus. And C&G, that was Ed Cowherd and Dean Goodman, the C&G part. And they had their program actually did do this multi-network least squares adjustments. And what they found out was, or what they did was, they coded in the very same algorithms that Elgin and Knowles used for StarNet. They brought into their program, their C&G program, and it was called ServStar or ServNet or something along those lines. And that became another reason that a lot of these surveying companies were buying the C&G software, because it included that same least squares algorithms that the separate StarNet program provided them. Well, Carlson couldn't really compete on that particular subject because they hadn't yet developed that multi-network least squares adjustment. And so as it turns out, at that particular time in the world, the folks at C&G Software were thinking about maybe trying to retire, and Carlson needed the algorithm. So Carlson just bought the C&G company entirely and took that code for that least squares adjustment, the multi-networks, and rolled it into their program. That's why it's there on that list as a separate menu item. It is a separate little program that runs when they bring it up. And that's
Ken,
also, yes.
if the different networks have different scales, is that affected when it's processing? The scale factor, if it varies.
The scale factor, yeah, well, in what we're looking at right now on this raw file processing, no, this is just simple traverse adjustment. But in the least square stuff, if you're traversed across many miles worth of traversing and your elevation data is up and down, and so you've got all kinds of different reductions to grid, those scale factors, those do get accommodated as they change, based on where you are geographically.
So
As
with
long
the multi-network setup, it'll actually accommodate the scale factors for the different networks, and then it will give you a general one based on your computation.
no, it will accommodate the both. It will,
Okay.
yeah, it will look at those based on where those are in relationship to each other, and then essentially apply little local ones, where they apply, and then as they tie in. So yes, they do accommodate that, but that's why you need that separate, you need the separate multi-network least squares adjustment. So, but anyway, that's how Carlson wound up bringing all of that C&G surveys software into their own, and because they bought the company and basically put them out of business as a concession to all of those surveying companies out there in the world that were using it, they allowed you to still use those commands with that C&G menu that you could see on your on your system if you don't turn it off. Okay, so so what this is going to do with their raw file processing, that we're going to get back to sort of step back away from the least squares part a bit, is this is going to allow us to do some of these, in this case, very simple, but we'll see when we'll load up another file with a little more complexity. And we're going to, use our compass rule adjustment, and do our closure computations and see how we're working to, how well our work has been performed. So also on this process menu, if you look at the bottom command of the menu, the process settings, here's where you can set a bunch of behavior that you want to put into effect as you're processing this. You've got tolerance values here that if you're using multiple measurements, like if you're setting up, observing a backslide, turning to the next traverse station, you're reading that in forward, you flip the scope, you close the horizon, you do a what's called a direct and reverse observation. So you get those as those multiple measurements. If when you're doing that, any of those measurements exceed whatever numbers you put in here, it's going to give you a little warning and tell you that, hey, this is outside that range. And that would flag to you that maybe you've, done a, had some kind of an error that you needed to either ignore, or if you could resolve it, if you could fix it, maybe you had some kind of, I don't know, maybe there was a change in the rod height or the instrument height or something, or you didn't put in the correct one or whatever, you know, it's just a way to flag that that might be a problem if it's outside that range. And then there's two different types of averaging that you can do for those, as you can either average the measurement of the distance itself, okay? Or you can average the coordinates that get computed, because each one of those observations is going to compute a slightly different coordinate value, and it's going to, you know, create, you know, all these different sets of coordinates. And if you take the average value of those coordinates, that's going to be your most expected position result. The distance measurements as an average type will allow you to average the distances. And if there were no change in your vertical accuracies and your vertical observations, then the coordinates that get computed would be the same. It would have the same effect. But this lets you take the vertical component out of that particular averaging of those sets of numbers, and then that applies it, you know, somewhere somewhere else. I'm looking for where it might be. Yeah, well, maybe on another screen, but anyway, we can tell it the same thing on the ad. Oh, no, yes, down at the bottom, the combining elevation method, you can again use either combine with the average or just take the lowest, or always do the combination to every record. So we're going to set that to average. We've got our average type at the top set to our distance measurements. And now the next little block down is for our backside orientation, is whether or not you want to override the entering azimuth, the starting azimuth, if you have a coordinate file. Well, if we have a coordinate file as control points, then yeah, we're going to let that control our azimuth, not, you know, what we type into it or what we observe with a compass. Okay. You can also have multiple backside references that can actually compute you a like a 3-point resection, if you will. You can store a backside point if none exists. Now, in this case, you look at this point 99 in our picture, and it's off down here by itself. And look up here in our data, and I see the only point record where I've stored a point is point number 1 of a record of 5,000, 5,000, elevation of 100. Okay. And then I've got my backside record says I'm at point number 1, but I'm starting it at an azimuth of 270 degrees. So maybe I'm observing like a steeple on a church that's across town, because I can see it from everywhere, and I happen to know, or I've got a comfortable starting azimuth, so I can use that as my backside, but I haven't actually computed a point. And so that's what this is going to be. If I don't actually have a point that I'm using, but I'm using these azimuths and things to observe that, I'm still wanted to go ahead and store a point for me, even if I don't have a point there yet. Okay. And again, the same types of distance tolerances from my backside checks, a little tighter than up here in my other checks around my traversing. And I've got a setting here if I'm doing checkpoints. And if you look up here in my spreadsheet at line 9, I've got a closing shot, and I'm calling that point, if I look here in my foresight point column, it's going to close onto point number 5. But if I look at my description, that description of point 5 is going to be Trav 5 but I also put in an equals 1. And that means that it's going to check in once it computes this point and it sees an equal mark, and that's what I've got set right here in this portion of my checkpoint settings, is if I have an equal mark, it's expecting me to tell it the point number that point is supposed to be the same as, okay? So as I'm doing this work, and I can do this either on the data collector or once I bring this in and I know that that's the one that's supposed to be that particular point, I can add that in as a check. And then it will report that for me and how well I've checked in on that particular station. Okay. Now my store point records, these are what we call store points, and that's where, and you again look up at line 2 in my data. This is where I stored a point number 1. I gave it the starting coordinates and elevation. So this is just a matter of whether I want to put that into the coordinate file or not, okay? I can say always put that in there, never put it in there, or only put it in if the coordinate file happens to be empty. So not exactly sure why and when you would want to do that separately, or if you just are using that as a starting point and you don't care about that point later, you could turn it off. But I typically put them in. And I want to report those store point records when I get my reports when I run. And I can hold the store points because those are the typed in, that's my known control typically. I'm going to hold those in any type of adjustments. And I can convert OC to PT records, meaning if I have these occupied points, the OC records for occupied points, I can convert those to a store point record for whatever reason you may or may not want. It's not typically something that's done. You can compare measurements to store points. So if you stored points up here, let's say I did a store point, 256 and the store point 125. Maybe those came from 2 other jobs or another job that I was working nearby on. Okay. So I store those points in my data on this work. And then I'm going to also compare any measurements to those store points as to when it calculates the measured result, that's my measurements, it's going to look at those, how well they fit those individual store point records. It's much like this checkpoint code up here with the equal mark, but this lets you also do it sort of more in a bulk fashion where we're actually going to check those against these store point records. Looking on the other side, we got some data checks. You can report any blank description. So if you've got any points or observations that are created without a description, it will show you what those are. And again, I've got my instrument height and rod height. Again, much like I've got up here, these tolerance values for horizontal and vertical. I'm basically saying if I get an instrument height that is less than 0 or greater than 7.5, I want you to give me an error message. If I have a rod height of less than 0 and greater than, in this case, 27.5, because maybe I'm using a real high mounted rod, on the top of a level rod or something, it's really kind of bad practice. I wouldn't normally have a reflector rod. It's almost 30 feet in the air. That's going to be too difficult to try to hold plumb over top of a particular point. So, but anyway, you get the idea. It just gives you a means of a range. So if it reads the data that was recorded in the raw file and it's outside of that range, it's going to report that to you. Right? And then the next block down are for direct and reverse settings. And this is for when you're doing multiple observations on a setup where you're, flopping the scope and closing the circle and that kind of thing. So direct and reverse vertical angles, and you can either balance those or only take the direct angles. Not sure why you would only do that. I think if you balance them, that's going to give you a better average myself. And then the same thing for the foresight and backsight measurements. You can have it balance those observations. So you're using those as a sort of an average between the two, or take the foresight measurements only. Maybe you're not recording the distances very carefully on your backsights, but I can't really see why you would do that, but it gives you the option there as well. And then you've got your horizontal angle tolerance and your flip angle tolerance. That's when you flop the scope and turn it around and read it in direct and reverse. So if those measurements are out by more than 5 seconds, in this case, for both horizontal and vertical angle, that's going to flag a little warning to you. Now, those numbers are going to be dependent on the accuracy of your equipment and how tight you do your work. So if you've got a 15-second theodolite that you're using instead of a 5-second total station or something, you can put in there 15 seconds or 30 seconds or whatever that tolerance might make sense to be. My distance tolerance, again, for multiple measurements, if I'm more than 2.5 hundredths out, it's going to flag that as a notice to me. And then finally, any measurements I make into control points, I can tell it that I want to store to the current coordinate file or not. And if I do that, it's going to store a computed position of a control point into my current coordinate file. And those control points can be in some other file. They don't have to be in my current file. Typically, we generally just bring them in as stored points. But I can store points into that when I take measurements to control points, or I can leave that unchecked if I want to keep those out and just use that to report how well I've connected. Finally, when we draw my points and lines, I can tell it if I want to draw by field to finish. I'm not going to, but you could do that. So if it were on, I would set a table, and so it would read these codes up here. You got trab 2, trab 3, all of that, and try to draw all of that stuff based on field to finish. I generally keep that as a separate process myself. When I'm doing traversing work, I quite often am not doing field to finish data collection. I'll run my traverse work first, use that as my control backbone, and then I'll go out, the next day or the next week, whenever I'm back out there, to bring in all of my field to finish type observations, knowing that my control points are well adjusted and they're sitting there ready for me to use. Okay. So that's sort of some of those settings and what they can do. And then and again, like I said, that's where these adjustments are that's where the process actually happens. But I've also got some independent tools that could give you some additional information, some different help and some insights into what you've got going on. You can run a direct and reverse report where it will simply write down in a report. It will list all of those, direct and reverse observations, all of the circle readings and the distance readings, much like what we used to write down in a field book with a pencil way back in the day. Okay, any of you gentlemen that might be old enough to have done your field work using field books, then that's essentially what you're going to get, is a report from all of those different measurements. And then you can separately reduce the direct and reverse observations to those averages that we used to have to compute for each set of observations on the fly in the field, subject to potential error. But you can go ahead and reduce all of those direct and reverse data sets, come up with the averages, and then use that to feed back into your processing. Okay. You can update a raw file from points. So if you've got points in a coordinate file that you're doing this computations, and then maybe you've gone out and moved a particular point in your drawing, and if you say update the raw file from that, then it's going to know that when you go back to reopen this raw file, it will look at these store point records and it will change the numbers. So in my case, I'm doing a store point of 5,000, 5,000, but if I've already got a 0.1 out here in my drawing, let's say it was, you know, if I'd done this the first time through, but then I found out that, okay, point number 1 is actually this coordinate, and I've got a nice, you know, geodetic coordinate value from it, so I can put that at the new value, then that particular tool will come in here and actually update the store point record from the new value that it reads from my coordinate file. Okay. Again, any field to finish substitution codes not typically done here at this stage. Now, finding a bad angle is just a little mathematical trick that helps us when we're doing traversing, which, without going into the derivations of all of that, it basically says if you've got a one particular setup that might be, you know, where at least most of the angular error is contained. Maybe you pointed at something incorrectly. Then if you run this tool, it can find you the angle, the setup where the angle is the one that's most appropriate for having missed closed when you close back in on the closing value. And that's essentially what it does is it takes the misclosure that's calculated at the end and it looks at its bearing and distance. And then it goes through and it finds the angle that if it were to have either widened or closed tighter, the angle at that particular point would put that closing value the closest to the starting value. Okay. And it does that by essentially looking at the bearing of the closing line of the misclosure, and it then constructs in memory a perpendicular to that bearing. So it's 90 degrees rotated from that bearing. And then it picks up that rotated 90-degree line and it goes around and looks at all of the angles at all the setups and tries to see if this most closely is aligning with the bisector of that angle. Okay. There's a similar technique to help you find the distance errors, and that would be if there's a particular amount of misclosure and it goes through and looks at the line where that distance might be the factor. And this again means that there was a bust, there was a distance error that where almost all of the error is contained in that one particular setup. And the way it will do that is it basically takes the bearing of that misclosure and it takes that same bearing, now not 90 degrees to it, but that same bearing, and it goes around to all the traverse legs and finds the leg that is most closely aligned to that same bearing, so that if that misclosed distance were either added into or taken out of that particular setup, then it would change the point along that same bearing to be closest to that original value. So just a couple of algorithmic helpers, although it doesn't have the distance one in here, it's just got the bad angle. Again, you can append other raw files, draw the traverse and side shot lines, and that means draw them into the drawing, not down here in our graphics. Okay, so that lets us do that if we wish. We can renumber points. There are coordinates, control coordinates. You can set a separate control coordinate file. So you don't have to do a store point. You can use a separate coordinate file for it to use for control. That's quite often done. But a lot of times we also want those points in our current coordinate file anyway. So, just your choice on that one. And again, you can then, and you can see you can edit those and list them, etc. And you can make point groups, and you can create, all of them, or just those that are the traverse points, or those that are the side shot points. And it goes through and it looks at all these records. Here's my TR, those are all traverse observations. So it would look at all these records and create a group that says, all right, all of these points, and those are the foresight points, belong to the traverse group. And if it was a SS record, a side shot record, which I don't have any in this data, it would do the same thing. Okay. And that's basically that. Help then is help, and it brings up this fairly extensive little help system that gives you some examples and stuff. So, but it's not that difficult to understand and learn and use, but it's a nice little treatment of, what everything means and how you would go through and do a couple of things. There's, let's see, compass report from open. Here's a typical SDR data file, wild or willed, however you say that in your part of the world. Leica raw file. And those are examples of what some of these things look like. Nikon, MDL, geodometer. Okay, so it's not a bad little, it's a seemingly innocent little command there, but it can put you in touch with something pretty in depth. Okay, so we need to we've jumped past our little morning break here as well. So let's go ahead and take a quick break here, and then we'll come back and run through this example and then get into a little bit more, show you some more advanced examples here after our lunch break. But let's we'll go ahead and put a little bookmark here and take about a 10-minute break. Let's come back at say 11:25. If that works for everybody there. Give us at least 10 minutes to get up and stretch our legs and make a phone call or two. And so far, any questions, anything that comes up with this? Okay.
So far, so good, from my end. But if possible, could we also see how to do an online check? Let's say you have 2 points, then you've created a new point in the middle of the two. You can do the computation for the new point.
Oh, to check if it's, yeah, you said online. I thought you meant you're going to log into some website. No, you mean the point on
No.
Yeah.
On the line.
Yeah, so check, that's a check for basically collinearity here. So, and I'm going to put their point online. Yeah, I'm jotting a note down here so we can make sure we cover that as well. Okay.
Yeah, and then also area checks.
And area checks. Okay.
Yeah.
Yep.
I think that's basically the two. If anything else comes up, I'll let you know, maybe in the middle of the training.
Okay. All right. Sounds grand. I will, like I say, I'll see you back here in about 10 minutes. We'll go to 11:25. We'll run through this real quickly so you can see it, show you some of the larger examples and see how we're going to use that. And then we'll go into the specific little checks and computations. All right.
Okay. Jerry and team, do you have any questions you want him to think about during the break? Maybe we could have him check and then get back to us when you come back from the break. Jerry and team. Okay, Ken, we'll see you after the break.
Alrighty, I'll go ahead and give us a pause and you can now see this screen here. So let's wrap up the little bit of the raw file processing, and then that's going to lead us very nicely into these other questions as well. So if you look at what we have here, I've got a store point, I've got a backsite, and I'm setting these next three, 1, 2, 3, 4 points, the last point being the the closure back onto the starting point. So and it basically just putting this little figure together. And a couple of things you might notice is if you click in a given line above, you will see the line and the figures and the graphics below light up. Likewise, if you choose your cursor to be the graphics cursor, which is this icon right here that's between the hand and the survey instrument. If I choose that, and if I pick a particular line or a point that go, let's say this point number 3, if I click on the observation that sets point number 3, now notice there could be multiples that set that point. But if I click on that observation, it's going to put me in the line in the raw file in the spreadsheet part that created that position. Okay, so it's a nice little way with larger data sets to help find your way around things pretty quickly. All right, so that's one thing to notice. Now, the other thing to look at our real simple example is we have a starting point. We are occupying point 1 and we're setting an azimuth of due west. And this back circle value, that means that's what we're basically zeroing the plates. So we're setting our circle readings to 0 so we can start our work. And then we do a traverse record. We're going to, again, we're sitting on point 1 and we're going to go to a foresight of point 2 and we're going to choose, see all these different codes here are northeast, southeast, southwest, northwest, or azimuth, or then I've got an angle right, an angle left, a deflection right, or a deflection left. Okay, so typically, we turn this angle right. So I'm sitting here looking to the left. I'm turning an angle right to point number 2 of essentially 180 degrees. And there you can see that, and it went out 100 feet. And I have a zenith angle of 90 degrees, and I'm setting that point as Trav 2. So now, because that was a traverse record, the next occupied point that you see in the next line is point 2, because I've moved up and I'm sitting on point 2 as my occupied point. I'm now going to set point 3, and that's going to be an angle right from 2, looking back at my last occupied point. Notice I don't have to make a new backsite record unless I'm changing it. Just traversing between 1 to 2 means that I'm sitting on 2, looking back at 1. I don't have to add that extra record. So 2 is looking at 1. I'm setting 3 by turning an angle right of 270 degrees, 100 feet, 90 degrees zenith angle, and setting point number Trav 3. I've now moved up to 3. I'm backsliding 2, and I'm going to set point number 4. And you can see that should normally, if I wanted to make a little square, that would have been 270, 100, blah, blah. But I've artificially included a little error in here. I missed it by 2 seconds, and I missed my distance by 200ths to set point 4. All right, so now point 4 is going to be backsliding 3, and it's going to do a closure shot to point number 5, which is also, if you see in the description, equal to 1. So it's going to give me that report. And again, I'm back to reading 270 degrees, 100 feet. We're good to go. And then when I sit at 5, my foresight point, I'm going to turn back around to my original backslight, and I'm going to give it from 5. And again, I'm looking back at 4, and I close that angle to 90 degrees angle right to sit on this point number 99 as my angle balance point. Okay, and I can see over here it's to close the angle. All right. So that's essentially my traverse. You can see my data is off in this one particular observation, but assuming we had some slightly different values here, how do we go about to adjust this data? So our first step is we go to process, no adjust, and this is just going to be a raw computation and comparison report to show you what's going to happen. So if I have multiple measurements to the same point, I'm going to average those. If I want to use my backslight reciprocals, that's if I'm flopping the scope and turning back around, I'm going to either not take any of those or average only the elevations, but I'm going to average elevation and distance, calculate my elevations. I've got point protection, notes, etc. And here's where you can calculate a combined scale factor to each different point, so you know where you happen to be on the world. Then your grid scale as well. You can have all of these different settings. Now, this is just dummy data, so it doesn't have any effect, but that would be where you could get those multiple grid factors. And again, it in scale factors, and it computes it for each individual measurement and takes that into account. Okay. Report angle is by the same format that's in here. I'll go out to 4 decimal places. I will report my closure. I can report any side shots. I don't have any right now, but now the last bit is that it wants to know the reference closing point. Well, I'm sitting on 5, but my closing point was 1. So that's my reference 1. It reads that value for those coordinates, and you can type in something new here, or you can just accept those as they are. That's what we're going to close on. So I'm going to say, okay. And it's going to either start here. It's going to ask my starting point number and my ending point number. And I can specify which are my traverse points from start to end automatically, or if I say prompt, it will do that as well. So I could go from 1 actually to 5. I could even go up to 99, I think would work. Let me see if that'll work for us. And then if I change to, if I say automatic and say okay, then it says error. The occupied point 5 does not match 4 on line 10. Well, it's not supposed to, actually. So if we do that again, no adjust, we're going to close to 1. We'll say okay. So now let's try 1 to 99 and prompt this time and see, maybe that was the problem. And there is the problem, because my traverse points went from 1 to 2 to 3 to 4 to 5, and then 99. I want to take that point out, so my traversing only goes to 0.5. I'll say okay, and it's still occupied point number 5 does not match 4. Ah, I see what it's doing. It's, I think, thought I did 4 to 5. Right, again, here's 1. Yeah, so 1 to 5, not 1 to 99. So that would, yeah, okay. So there we go. So it didn't allow me to use that 99 because I didn't actually traverse through that. That was just my starting azimuth as a backside. So a couple of things in the report, your typical raw file, coordinate file, scale factors, corrections that we may or may not have applied, which we haven't got any for this dummy data. Here's my closure results. I have a starting point 1. I have a closing reference point, which happens to be the same point. And I have an ending point computed by raw value to be 1/1000th a foot off in the northing and almost 2/100ths of a foot off in the easting. And there's your equals 1 business. So you see my azimuth of error is almost due east and west. It's 92 degrees and it's missing 0.001 in the north, but it's missing 0.02 in the east. I had no vertical error, of course. And my distance, so basically that, is the square of this and square of that, the square root of the sum, gives me the 0.02 total misclosure. 4 lines, side shot the store point. There's my distance, which should have been 400, but because of my error, it came up wrong. And I've got a closing precision of 1 in 21,000. Now, I'm old enough to where when I was first starting out in this business, that was an acceptable closure for a traverse, and we'd dust our hands off and go on about our business. Really, it's pretty poor with today's instrumentation and technique. So I think we can do better than that, and we see some of the ways we can do that. So next we've got the point number, the horizontal angle, the zenith angle. This is just a record of the observations that were taken from the raw file. And then the side shots, and this one last side shot, because it was not a traverse observation, it classified as a side shot. And but it does say that it was the close angle record. Again, a summation of all of the points that I've stored. So my store point records, and I just did the one, and then my checkpoint reporting. I said reference point 1, measure point 5, and right there's the difference between what those points are. Now, if I had other points that I'm checking into, I don't have to, it's not limited to just one point, okay? All I have to do is put that equals in the point number for the other ones as I check in, as I go through the traversing. It will report then all of those different misses for those particular points. And then it gives me the horizontal distance of the misclosure again, and it tells me on my line number 9, occupied point of 4, a slope distance of 100, horizontal angle 270, and that's where it's thinking the misclosure happened to be, although it was actually the line before it. I'm not sure exactly what that line might represent, but that's our just basic raw computation with no adjust. That was the first step that we did. We ran a process no adjust, okay? So if we exit that and let's go to another option, is let's do an angle balance. Now, what this is going to do is it's going to leave the distance measurements alone, but it's going to spread the angular error out among all of the angles and compute that and show you what that's going to look like. So if I do an angle balance, again, much the same thing here, but my reference closing point down here at the bottom, again, I'll put in 1. I'll say, okay. There's my traversing, say, okay. And now it wants to know the reference closing angle. So it's measured closing 0.5 to 99, and that should have been, south 90 west or due west. The measured closing azimuth is 269, 59, 58. But my reference closing azimuth actually should have been 270. I think this will be what I want. And I'll say, okay. And now we have again the raw file, and here's our closure results. Notice this is before angle balance. And that's the same numbers that you saw before, 1 part in 21,000. And now we've got this record of the observations, the store points. So this is much like you saw before. And then down here are my checkpoints. And then we start the angle balance portion. And it says you've got an angular error of 2 seconds for 5 traverse sides. Therefore, we will adjust each angle by 0.4 seconds, and that will spread it through. So now our closure after the angle balance with those starting and ending coordinates is, let's see, we're going to have a northern error here and eastern error, so we didn't really tighten it up very much at all. So 0.1943, up here above, we have 0.1906. We've actually gotten a little bit worse here. And let's see. So we now have a closure precision of 1 part in 20,500 instead of 1 part in 20,900. So it went down a little bit. Okay, but it's just if we had some normal data that we would see that a little bit better. Okay, so it just gives us that report of our information. So then finally, let's go to the process command and choose a compass rule adjustment. Again, our reference closing point is point number 1. And right here is where we can choose whether or not we want to apply the angle balance. Okay. And if we don't do that, you can see, and there's your calculated combined scale factor for each measurement again. So if we do apply the angle balance, it's going to be as a 2-pass process. It's going to balance the angles and then go back through and balance the distances and apply the compass rule. But I'm going to say, I'm going to uncheck that and just let it balance the raw stuff directly. Okay. Report the unadjusted points, report any adjustments, report any side shots. Good to go. We'll say okay. Again, 1 to 5. Say okay. And now here's our results. Here's our initial closure results. The same thing we saw before, 1 part in 20,990. Down here's our record of observations, our record of store points, our checkpoint reports. And now here are our adjusted elevation comparisons. And again, we don't have any elevation differences, so they're no problem. And now we do the compass closure with these adjusted point computations. So I've got an original and an adjusted 0.2, 3, 4, and 5. So because 5 needed to be the same as 1, which was 1,000 or 5,000, 5,000, you can see the adjusted value is 5,000, 5,000. My computed versus adjusted, you can see those for number 2, 5,100, it gets 5099.995, but the northern didn't adjust much at all. It did by these distances and along those bearings. So I had a maximum adjustment of 0.02. Might consider that okay. And now from these, after it's doing this adjustment, it recomputes what these values would be to calculate the adjusted position. So you can see that instead of an angle right of 180 at 100 feet, it should be 179, 59, 60, which is just a roundup issue. But the distance should be 99.9952. So anyway, it's given you what these observations would have been had the, had it been perfect for you. So that's the adjustments that it's done. Okay. So at that point, let's see, I'm not going to save the report here. So at that point, then I've actually got the coordinates done, and I can, I could just come here to the file and say, save the coordinate file. I can exit, do everything about that as I wanted. Again, I've got these, say find the bad angle, and I don't know that it's going to find it here because of this, although I do have a bust all in that one observation. So that should be, where we set point number 4 is line 8 here. So that's where the angle bust is. But I've also got a distance bust there, so that might throw it off. But let's see what it gives us. Same thing. And as it goes around here, now my closing point is my referenced, let's say the measured closing points 5 to 9, my measured closing bearing. So 269, 59, 58 should have been the measured closing azimuth. If I switch to azimuth mode here, that should be 270. I think will do it for us. So we do this, and it says, let's see, here's my store point. Here's my checkpoints. And find the bad error. Says, okay, you've got 2 seconds. The bad angle was at setup 2, foresight 3. Now, if I go back to that setup 2 with my foresight 3, that's right here. You see, it didn't actually find it correctly. Okay, it found the first instance of where it was sort of parallel to it or perpendicular to it. But really the error was down here. Okay, so that is just, like I said, a tool. It can sort of maybe help you find where something's happened, not necessarily a guarantee kind of thing. All right. Now, let's do a real quick look through as again at a little more lengthy example. So if let's go ahead and just exit that, save the coordinate file changes. I'm going to say no. Go back and do edit process raw data. And let's choose this time, instead of that raw file 1, let's look at raw file 2. And we open that, and you see something a little bit more. And yours might look like this, where you're showing all of the side shots or not. If I toggle, and that's the same as display, graphics, we'll turn this whole thing on and off, but I can down here say show side shot records or hide side shot records, and I can toggle that with my little SS up here so that I'm only seeing the traverse records, but I've got all of these description records. Now, these are things that are either, typed in as descriptions or they're recorded in our data collector. Here I've got 2 store points. I've got point number 5,000 and 5,001. And you can see as I click that down below, they're going to light up. So I've got a store point over here of 5,000, a store point in here of 5,001. It's sort of hiding under that multiple. There's multiple points in there. That's why we can't really see that unless we can, let's see. It's not the easiest to zoom in and out of, so I probably can't even see it. It's tiny enough. But anyway, there's where 5,001 is. So let's go back. See if I've got a. See if I've got an actual view or zoom all, but there we go. So I'm like a zoom extents. Don't really have a zoom extents in this little viewer. So in any case, so what we got here is, again, these various records, and you can see all of these descriptions. They're taking up a lot of space. If I wanted to hide those, I could go to display, hide description records. So now I'm just looking at the data. So now I've got these points. Those are my store point records. You see I've got store points, traverse, side shot, HI, backsite, DS, which is a description record. CL is my closing shot. AB is my angle balance shot. CL and AB means that shot is both a closing distance and an angle balance. Then I've got foresight direct, foresight reverse, backside direct, backside reverse, elevation, azimuth, et cetera, et cetera, et cetera. All of these different types of observations that you could have by choosing that if you're entering this manually, or you may even add and choose these, and it will create those and use those particular codes that tell it what it is. But this is how this was recorded. So my very first, I've stored the points, I've entered an HI. I did not have an HR yet until I went to this next observation down here. I took a back sight shot here. So I was sitting on 5,001 looking at 5,000, and I measured the rod height with another HI in here where I set the rod height to 4.95. So I'm with 547, now 4.95. And this is something that's very common. Let me point this out to you as well. If you sometimes, you've done a bunch of traverse and you bring these in and you see that your points all look, they all look good, like they're in relationship to each other, but maybe they're rotated pretty badly with the way you know that it should be lined up. I've got a colleague that he does this a lot. He's an older gentleman that's learning to use this a bit more. But one of the things that he'll forget to do out there in the field in his data collector is he forgets to zero the plates. And it's this back circle. And it comes in. So he's got something, goes, yeah, everything is okay, but it's all turned around, you know, like 45 degrees rotated in space. And so we open up his raw file and I'll see that right there. He doesn't have an entry in his back circle, or he has an entry, but it's not zero. And so we back up, we put that in there for his circle reading. And then once he reprocesses it, it goes through and puts everything back where it's supposed to be. Okay. But this is another example of what the raw file will do for you, is allow you to create these records, and not just with, you know, from field observations, data collector, but also from computing points in the office, coordinate geometry computations. If we keep that raw file record of that, then we can always go back and, oh, I forgot to put an HI, or, oh, I forgot to change this, or, oh, hey, I see that I mistyped an angle. Then you can go back and fix it and not have to do all of that other stuff again. It just recomputes it. Okay. So that's the whole idea behind it. So now I've got a bunch of side shots, side shots, side shots. You don't see them down below because we've turned that off. But if I turn my side shots on and I now look at, say, this one, And so I can see. So you can see here, right around that one point, there's just all those side shots. I've got, there's 4001. There's 4002. If I switch to my pointer cursor and I go to click this one down here, well, that was to 3309, and it came from 3190 was my occupied point, okay? And let's see what this one is, 3317 or 3314. Sorry, I missed my pick. So that takes me right to that individual record. And you can see what it is that I've done. Here's one that's called FL. That's an actual, it is a side shot, but it's computed as a fly line that they're talking about. So he goes out to sort of throw out some, control out to the side somewhere. So it doesn't have to, like you see all these descriptions say SS, they don't have to all say SS. It's just, he's telling that that's a side shot. Okay, so the fact that it's an OS over here in the record type controls that fact of being a side shot. All right, so I'm going to turn my side shots off. So we can just see the traverse work. And now you got a sort of interesting dilemma. You've got this 5,000 and 3190 over here that don't really do much. There's nothing I do. 3190 itself is that, if I go to that, see, it's a side shot to 3190, and it's a side shot trav. That's sort of that little fly line that it's putting out here for us to be able to set some side shots off of, but it doesn't connect back into anything else. Pretty bad survey technique, obviously, but that's what this data is going to show. Okay, so let's take a look then at our process routines. We'll just run through them real quickly. We're going to say no adjust just to get the raw stuff. Now, where is my closing point? Well, I was at 5,001 to 2 to 3 to 4 to 5. And I don't know what that other point number is. There's 5,006. Let me see what that observation is. That goes to 7,001. Okay, so 7,001 is my closure and angle balance. All right. So now process, no adjust. My reference closing point should have been 5,001, but we've got a 7,001. And you notice up here in the description, it also says equals 5,001. So that also confirmation. So we'll say 5,001, that's what it should be. And we'll see how it works. We'll say, okay. And it's going to start and end 5,001 to 7,001, which closes back on itself. Again, not a real robustly imagined traverse. We really should start on two knowns and close on two other unknowns, not close back to ourselves, but sometimes by expediency's sake, this is what we do. We'll say, okay. Now, here's our closure results. We have a total closure here of 1 part in 139,000. So not too terribly bad, even just by raw computation. But there it is. There's now our observations. As we go here, and there's a bunch of side shots. Now these are going to be huge because we've told it to report the side shots. So we'll scroll down here and then look at my store point records, my checkpoints. I've got a 5,001, 7,001 equals 5,001, and this is how closely I hit that. Okay, and I've got a misclosure of 5 1,000ths. Okay, and you can see the difference as to what I did coming into that. All right, so that gives me an example. I'm gonna go back to, let's run an angle balance now and see. And I'm gonna uncheck report side shots. And now 5,001 is my closing point. And my reference closing angle now was from 5,005 to 5,001. So I measure closing. Smith. Reference closing angle, so 5,005. I'm not sure if I'm gonna do this exactly right. Let me see what that happens to be. Yeah, I'd still need to know that. I still need to know what that is supposed to be. I actually don't know that value yet because these are not closed. I'm not closing on a known value. So that's actually not going to help me there. So then I will go straight into my compass rule. My reference closing point again was 5,001. And I'll say, okay. And so off it goes, runs the very same thing. There's my initial closure precision. Down below are my adjusted point comparisons. There's my elevation comparisons. So slight little tweaks. You can see less than 100th in every case. And then my adjusted points. Again, less than 100th in every case. My maximum adjustment was 5/1000ths or half a hundredth. And finally, I've computed my final adjusted coordinates. And I would say, I would exit and say, save the coordinates values and go from there, right? We can also, if we go to our tools here and we say draw traverse and side shot lines, I'm going to draw traverse, but not side shot. And I've got some side shot traverse lines. So it did that starting point. Five thousand or 7,001, correct? And okay, so it drew those for me here. And if I exit, yes, go ahead.
I want to ask, can Carlson generate a report for just the machine setup, like how accurate you probably set up the total station?
Yes, so you mean can it tell how much it might be missing sitting on top of that station, do you mean?
Yeah.
No, not directly. It doesn't have any means of doing that. There's no real, the only thing it can do is if you know that this is the absolute, the absolute golden correct coordinate value for this particular point. To be able to generate a report like that, you would have to do a series of measurements around to that point. And
Okay.
yeah, so it's much like when we did this with that point 7,001, which is supposed to be 5,001 to 2 to 3 to 4 to 5, and then back to 7,001, which should have been 5,001. Then, it would, in that particular misclosure, and I don't think.
Yeah, because I'm asking because most of the times we sometimes combine the use of the GPS observing with the GPS with the total station, right?
Yeah.
And then the total station comes in at points where we find it difficult getting good readings from the GPS. Right, so what I know is we hardly go through a process where we have to do a traverse and close back. So I'm only thinking that, I mean, if we could actually generate the report for our setup, then I mean this could really be of help. And that made me ask that question.
Yeah.
Because I've not seen us quite close.
Right, right. Yeah, I mean, no, certainly a great question, but here's the limitations on why it can't, and the reason it can't give you that directly is that how is it going to know where the instrument is sitting? See, it doesn't have any sensing capability of being set up over this point. It knows what the point is supposed to be because you've told it what those coordinates are supposed to be, but it doesn't know where you are actually sitting until you can measure to that point. Okay. So in that case, those are those check-in points where you do that, the 7,001, it had that equals 5,001. So that's saying, okay, this is where I'm supposed to be. I want you to compute this and tell me where I computed that I was, and that's how much difference I need to take out of that. So it can't really tell you that. And one of the things might be that if maybe maybe you suspect the GPS value of that point that you're using as a control station, but there's no way of knowing how good that particular record is other than
Okay.
yeah, until you measure where you're supposed to be. So if you're just setting up the instrument, there's no way that Carlson or any other software can tell you how well you're setting up the instrument, because there's no sensory information given about where that instrument is, okay, until you measure to it. So in that sense, yes, it gives you that misclosure with those equal marks, but until you get to that, then no, it won't, right? So now just one real quick other further example.
Ken,
Yes,
just to add on to that, I think what he's trying to look at is you have 3 known points that were established using a GPS.
okay,
So, but you have other points you're trying to set up or to establish for your subdivision. So there's this aspect where you need to do a field check based on the 3 known points. So
all
you
right,
take your total station on 1 known point,
yeah,
do a back site, then do a check on another known third point to see
okay,
if they agree and the disclosure.
yeah, oh yeah, no, that's exactly what
If I do such, can I get such a report from the Carlson software?
yeah, well, that's exactly what that is that when you have that code in there for equal, let in our example, like that 7,001 point was
Yeah,
supposed to be the same as the 5,001 point.
exactly. So
And
like
so
the
that
5,000, sorry.
no, I'm saying, so what it will do is it reads the observation that you've just made over to that, but what is supposed to be another known point, and it just shows you that. Let me run through this again. So that's
Yeah,
5,001. Let me
like
hide.
for example, 10. I'm
Yeah,
at 5,001. I've
yeah.
arrowed to 5,006. Then I've checked with 5,005 to make sure that 5,001, the bearing and the disclosure is agreeing.
All right. So we've got, in this example, we've got these 2 known points,
Yeah,
5,000 and 5,001, which is under here. Okay. There's
yeah,
also 7,001. So what we've done is we've we've done our first backside. We've said we're sitting on 5,001. We're backsighting 5,000. Okay.
Yes.
And then we're going to set, of course, they set a bunch of side shots first, but then we're going to set to, from 5,001, looking at 5,000, we're going to set 5,002. So right there's our first little point that we did. And now we could have just turned around and shot to 5,006 if that was a known point.
Yeah.
Yeah, then we can certainly do that. But then for 5,006, all we need to do is put in equals whatever that number happens to be if we've got a number. So we would give it a different number. Let's say we had this 5,006 was our known station, but we might say sitting on 5,001, backsighting 5,000, then we then turn the angle, measure the distance over here to, and we might call it point, 9999 equal 5,006. So the very same thing that they did, they computed their way around here to 5,005, and then the next one that they went up to here was actually 7,001, and that was on this record. I'm going to select this leg. So that selected this point number 7,001, and over in its description, I said equals 5,001. So that is supposed to be that known point. Now, getting to that point, I've gone through these other points, the 02, 03, 04, and to 05, and then calculated that. I could have just with a single setup, like we talked about in 5,006. I could have gone from 5,001, backsighting 5,002, and just turn right around to that other control point right there. Okay, just one observation. And I would call that point 9999 equals 5,006. And then it's going to do a thing like, just like this did, is this checkpoints. It's going to show you what the reference value is. That's the published position. And then it's going to show you the measured value. Okay, so that in that sense, and then it shows you the deltas down below. Okay, and what does that to be? So in that sense, yes, it can tell you basically the quality of that point, of that 5,006 point. Okay, does that clarify?
Yeah, that clarifies now.
Okay. All right, so real quick.
So question,
Yes.
so any shot that you want to take to a point to use as a check, you would write equal the point number of the datum value.
Yes, the point number. And that is controlled by this right here under our process menu, our process settings. It's this right here. Okay. So it says and you have to turn this on too if you want to see those checkpoints. You have to check that you want to look at them. And then when you take that observation, and you can do it after the fact, you can add it in here, or you can add it in the field, in the description of the point in the field. You give it whatever it happens to be. It could be, it doesn't have to just say equals 5,001. It could say, PK nail equals 5,001. It could be whatever it needs to be. And as soon as it hits that equal mark, it tells it to go and look for that other point number and compare it. Okay. And now I'm using equals, but you see this code, I could say, instead of using equal, maybe I put a
Underscore 5,001.
Yeah, or a dash CHK, meaning once it sees dash CHK, then that's the same as saying equals, then it's going to look for that point number to follow. Okay. So equals just makes, the most logical sense in terms of we're saying that point equals this point. All right. So now let's right quick in the 5 minutes we have before stopping for lunch here. Let's look at something that's even more complex than that. As soon as it loads here. And you can get an idea of what they're doing with this. You know, it shouldn't be taking this long to load. They could knock something out of whack. There it is. Okay. Yeah, it's got some kind of background process that's doing this to me. This is courtesy of Windows. Nothing to do with Carlson, but in any case, you can see, you know, it's a much more robust traverse, and it's more than just one traverse. This is, you know, maybe this western portion was done on one day and then the eastern portion. So here we go. Now let me turn this off. See, minor third, add. So let me hide these description records. Okay, so as I look at these, I've got, you know, say this point number 1 to 2 to 3, and it goes all the way around here and computes back around and closes back to itself. There's this little fly line out here on the side here. But then I've also got this set of observations that went from 160, 161 and comes around, you know, that a little networking here. And then there's a little, maybe a little sub network in here as well. And there's all kinds of little check-ins and outs. So if I look at, say, let's see, I think we might be able to find. All right, here's a description that says CK46. Here's one that says CK48. And I think that's what they used was, I'm going to check 0.46, check 0.48. But, you know, we have our code being equals, but I'm not really sure what they may have done. They may have used that CK as a code instead of equals, because this data, this is actual, you know, this is real data. This is not, you know, just dummied up data from Carlson. But I don't know the history behind it, but you can see I've got all these little little flies and ties, and I've got these multiple networks that are all linked in together. And so in this particular example, you know, that I've got, you know, here's a little sub network that was run off of this main run that came through here maybe the first time. And then they started here and ran a series of observations around and then tied back into this other set of controls. So that technically is a traverse all by itself, tying in from 2 nodes out here to 2 nodes out here. But because it's all of this, you know, multiple networks and multiple traverses at the same time, I can adjust all of that stuff at the same time using least squares, but the raw file will actually control it and record the information. And we would see all that in the least squares adjustments part as well. Okay, so that's what we can use that for. And then when we come back after lunch, we're going to look at these other computation techniques and also show you by using that raw file, that same idea of how we can keep track of those computations and go back and use them to you know, sort of as an audit trail. So it's like the difference in calculating a bunch of numbers with an adding machine. And if you make a mistake, you've got to go back and do it from that point forward again. Or if you use a spreadsheet on your computer, all you have to do is make the correction to the one entry that was wrong, and everything else stays the same, and it just recomputes. Okay, so that's that same concept. All right. So think of anything else that you might want to go over in the afternoon session. And when we come back, we'll do that and wrap things up. Okay.
Ken,
Yes.
are we going to touch on subdivisions in the afternoon?
Yeah, we can do that.
Okay.
Yeah, so we'll do some let me do some parcel.
We can touch on COGO and subdivisions in the afternoon.
Yes, some parcel computations.
Yeah.
Yep, absolutely. Okay. So
So we'll
any,
touch on translation for COGO as well.
I'm sorry, what was it?
Translation for the COGO.
You mean like picking up the set of points and moving them to a new location and rotation, that kind of stuff?
Yes.
Yeah, okay. So translate, rotate, basically transformations.
Yeah.
Yeah. Okay.
And cluster point report as well.
Oh, okay. I'm sorry. I'm having a real hard time hearing. There's
Cluster point report.
last points.
So if,
Yeah.
Ken, so if I have a point and I've taken some other observations, I just want a report to show that how close those points are to that point. So can Carlson do that for me?
You mean like those multiple checkpoints?
Yes, so it was, these are GPS points which were probably brought in to the Carlson. But I have a particular point, coordinate for a particular point, which I want to see how accurate those points are compared to that exact point I want to have.
All right. So were you saying then cluster points?
Yeah, usually that's
That's the technology. Maybe it is different for you.
Yeah. There's a number of ways we can see that. I'll over lunch, I'll look at the best way of doing that. I mean, there's a number of ways we can do it just by running inverse reports. That basically calculates, you know, all of the distances between a given known point and a bunch of other points. So we can we'll take a look at that, and I'll see about maybe the best tool to give you that given certain starting conditions. Okay.
And then something else, Ken,
Yes.
with annotate command in Carlson. Could you show us how to get the bearing and distance between 2 points? Because
Sure.
we are having an issue. We have 2 known points. When we compute it manually, we're getting a different value from what we're getting from Carlson. Maybe there's something that we're doing wrong.
Ah, okay.
By that was.
Okay, perfect. Yeah, so if we annotate or compute bearing and distance, and then you're saying if you and you're checking it by, how are you checking it? Just by like a calculator?
Yeah, calculated.
Okay. Yeah, that would be very interesting to look at. You have to show me what you're doing so that I can see where that's showing up, because it's entirely possible. I'm not going to say it's likely, but it is entirely possible that you've got a situation that is a bug in the software. I don't think so. I've done all these checks before. I've never run into that before, but if you've got an example with some points, then we'll take a look at that and see. Maybe I'll have you share your screen if you've got something there that you can show me where they are different, and we'll see it. Okay.
I'll send you the coordinates for the 2 points,
Okay.
and then maybe you can check on the 2 points.
Okay, sure. Yeah, that'd be great. You let
Okay.
me know those, and then I'll I'll do the checks and see, and then we'll see if maybe there's something that you may or may not be doing correctly on doing your annotation. Okay,
Okay, okay.
so I'm going to say, I'm going to check my email for that when we come back. All right, so. All right, great. Any others?
I would want to add this, how to print according to the skill, like how to print in skill. Probably you can end with that.
Okay, you mean like if you're doing that on a particular like a drawing
Yeah.
sheet, how to set
Yeah.
that up?
Yes.
Yeah, that's I mean that's actually not so much a Carlson function as a CAD function, but I'll try to leave some time that we can run through that as an example. In fact, a really good example that we can do is we can use with that is from yesterday's file that you sent me already. I think, let me pop it back up here and see. And that was the 37, 377, this file here, okay? So like
Yeah.
I know that you've got this, and I can see what's been done, is that typically, once this gets up there, you know, typically, everything's drawn out here in model space. And so you've typically done that, and maybe set it to a particular scale, but really it should be done over here in layout space using a paper tab, because I can do any given thing, and I don't have to, and I would put all of this title block stuff, north arrows or whatever, in my paper, because this is really just the model, just the geometry. And I might have a sheet that shows everything like this. Of course, I'd have it rotated. And then I might have another sheet that maybe I'm zoomed in here and just showing a real tight example around the building. So that's a really good example to go through this with, and I'll show you how to go about that. Okay?
Okay. And then, Ken, if by any chance you might be back a bit early, maybe 5 minutes earlier, I would like you to have a small discussion with Jerry in regards to his Carlson. There's an issue with the registration of his software.
Oh, okay.
Yeah, so we can discuss that a bit earlier before the session starts.
Yes, I'll be glad to do that. If all right, so I'm going to I'm going to let you guys go ahead and go ahead and take your full hour here, but I'll come back at 1:30 right on the dot.
Okay.
So I'll be there. And you're all welcome to come back at 1:30 if you want. I'm not saying you have to stay away, but I don't want to deprive you of your lunch hour either. So if you come back and then let me see what's going on with the registration, I may be able to help you. It might be something you have to get in touch with Carlson technical support. Because I don't really do a lot of that particular type of administration, but I do some, and it might just be something simple. Okay.
Okay.
Yes, sir.
All
Thank you
righty.
very much.
You bet. I'll
Thank you.
see, yeah, I'll see everybody back. Like I said, I'll be back at 1:30, and I'll see everybody else at, say, 1:40. All right.
Okay. Okay. Thanks.
You bet.
Bye.
So, a couple things, had some good questions right before the break, so we can take a look at some things that help us out here. So one of the things we wanted to look at, you sent me the coordinate file. So I went ahead and made a new coordinate file here called cadastral to match your name. So if I'm going to import those points now, I'm going to select my file, which is my cadastral observations. Looks like they are all right. So what is my format here? I've got BB 3767.1, comma 71550. and then an elevation. All right, so can you help me out and tell me what these are? It looks like maybe the descriptions are first.
The description is first, then there's the northing, the easting, then elevation, then the point description, I think.
Well,
Like
Like-
the 7-1, yeah.
see, like this one here is in here twice.
Yeah, so it was observed twice, then they averaged the two to get now the exact coordinates for the point. So it is the first fix and the second fix.
All right, so if I were to tell this that this was in this format, I'm going to say that it was the description is first. So instead of the point number, it was the description and then the point name or number. Now the problem I have with this is that you're going to get all of these duplications. And they,
Okay,
so in fact, it looks like you got a whole bunch of 717s and 718s, or
No, the 717 is the code.
yeah,
So
Oh.
we use 717 for first fix, 718 for second fix. So these are
Oh.
GPS observations.
Okay, all right, that makes better sense then. All right, so the first one, even though it might be spelled out as a what looks like a description, it's actually the point name itself, the point
Right.
yeah, so you got like that C
So
place
C
magnet.
place Magnil, that would be the first fix with
Yeah.
717 descript code.
Right.
Then
And
C
the
place
718
Magnil, that two would be the second fix with the 718 code for
Yeah.
second.
And so as long as that makes it a unique identifier like the dot two on the C place magnet, that's fine. So if now I've got the format is just pretty standard. The point name, that's the P, the northing, the easting, the elevation, and then the description or the code. Either way, that's going to be what we have. So I'll now do that, and it says the point C placed magnail has caused an error. Let me see what's causing the error here. Let's go to settings. Carlson configure general settings. Let's make sure I can use alphanumeric. I can. So that should be okay. So if all right, so C placed magnail. You know what? It's almost like it's reading these spaces and it's apparently not allowing the spaces. It should be connected like this. So let's fix that part first. All right, so I'm going to let's go to that CSV file. I've got my Carlson projects, class data sets, type. I've got a CSV, or maybe it calls it Microsoft Excel. There it is. It's a CSV file. Okay. So if I look at that, why can't it be imported? Let's see here. Let's try this way. There we go. So I think what was causing that to be a problem were the spaces. So what we're going to do instead then is to take all of these spaces and replace them So I'm going to find and replace. I'm going to look for a space, which is a quote, space, quote. And I'm going to replace that with an underscore. Maybe I don't need the quotes here. Let's see. Yeah, 28 found, replace them all. Okay, and now. So now when I bring these in, they'll have underscores in there and it shouldn't be a problem for me. So I'll now close that and we will keep the new document. I'll export there. Go back to our data sets. Same name, export, yes, replace. Okay. Now, let's if we import our points, select our file, cadastral, and we have that same business there. And say, okay. Wow, what's the problem? Maybe that wasn't the error. C placed magnail has caused an error. C placed magnail, comma, northing, comma, easting, comma, elevation. Okay, yeah, no elevation, and then code.
Could it be the description is too long?
No, it shouldn't be. It shouldn't be, but that's a possible. So let's go back to that possibility and see. Yeah, it's not showing up where I wanted it to. All right, so my Carlson projects. All right, so it could be, let's change a couple of these. I'm going to say, let's find and replace. Let's call it placed magnail. I'm just going to, I'll leave the C like it was, and we'll just call this mag. And to maybe head that off, we've got an IPC found. We've got found. Let's just replace found with FND. All right, that's definitely within limits. All right, once more into the breach. One, two, three, four, five, six, seven, 8, 9, 10, 11 characters. This is getting old. Data. Where was there's 11. There we go. And Carlson projects, our data sets, our cadastral observations, and that was the DIPC find one. Yeah, we'll make that two. Let's call that let me see. All right, so
Can-
you get a
Considering there's no other IPC, can we just put it as IPC?
Yep.
IPC 1, 2, 3, the way it is. Just
Yeah,
remove
we'll,
the D.
yeah, we'll take out the D. All right. Now, let me see. Is there anything else that might be causing that? I don't see it. Come on, you gotta be kidding me.
So data is a wiki data.
That really, shouldn't be. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so it makes it down.
Percy,
So let's just take these L finds and just call them L's.
the L finding will just come up now.
Yeah.
So L underscore FND. We're just going to call L. So if it's a character limit, if it's a number of characters, that's going to be a problem. We're certainly less than these ones above, so that should work for us. I'm hopeful this time. All right. Selecting the file. Cadastral observations. We scroll down and see, yep, everything's good. Say okay. Rating 21 points. Skip 17 duplicates. Oh, come on. Let's go to erase points by number. All. Yes, yes, yes. And do it fresh now, because apparently every time I interrupted it, it's still stored from the last go. All right, so back clean, 21 points. There they are. Okay. Now, we look at those points in our listing and we see that we have those as point numbers, or point names rather. And then the description is simply the code. All right, so what is it that we need to compare here? How are we going to do a comparison? And I see I've got some points that are sort of on top of each other here. That's fine. I've just drawn them in here. That doesn't see if I can draw locate points here. I'm going to change.
So, Ken,
Yes.
Percy and Jerry will correct me. The points, the ones you're seeing on top of the other, that's a first fix and a second fix of the point.
Okay.
So we wanted to see a comparison of the first fix and the second fix. If Carlson can do that for us,
Yeah.
then we would like now to see as well in terms of calculating bearing and distance between 2 points
Okay.
using annotation.
Yeah, basically, we draw a line from one point to the next, do a list, tell it to give us a bearing and distance, but then if we annotate that line, it should be the same bearing and distance as what we would ask it under the command using list, bearing distance. Because I'm finding different in my Carlson. Now that it's registered, maybe it might change, I don't know.
Okay. So let me see if I can get to these. I'm trying to fix the overlaps here. Move block. There we go. Point label to move. Let's try this one.
Ken,
Yeah.
is there a setting in Carlson where you can set it to not overlap the point attributes? The
Yeah. That's what it's doing right here is this little fix overlapping attributes.
Hmm.
And so it was just going through those to let me, it said, hey, here I found you some overlapping attributes. So let me move those options. So there may be, whether I've got one that says autumn.
or you have to still go through and move them.
Yeah, but I mean, it's showing me where they are. I'm wondering if I can do that as an automatic thing to do.
Because in our workflow, we have a lot of what you call
Yeah,
overlapping points.
yeah, you have too
Because
many.
we are required to fix GPS points twice
So 3 times.
or 3 times, depending on if it's a control point or just a regular field shot.
Okay, so
So for a lot of our points, we will have 2 points overlapping each other, or 3 or 4, depending on what's going on in the field.
yeah, so right here, if I fix these overlapping attributes and if I just draw them all, then here's what I'm going to do. I can use the leader, auto justify at minimum offset, draw the tick, draw the arrowhead. Okay, those are all good. but review remaining, that's what I wanted to uncheck. So maybe that should automatically move them for me. 14 overlaps found, 0 fixed, 14 remain. Why? All right, fix overlap, draw all. Alternate layout, offset. Slide individuals, okay, overlap manager. Avoid line work, I don't need to worry about that. Use selection set for points. Use the leader, auto justify, draw the tick, draw the arrowhead. All right, so that should work, although I think it's still gonna make me review these. Now, if I can do this from here. See, it won't let me. It's gonna make me answer it's gonna make me answer the question, basically. As I go through these. All right, so let me see if my options are. Yeah, it won't. All right, I think that's got us now. Is that correct? Status is resolved. So I still got one I see there, right? Okay, so now I have some numbers. So if you're looking at this 9129.1 compared to 9129.2, or maybe even J1 to J2. Pull this down, make sure, okay. So J.1 and J.2 are basically supposed to be close to the same point. I can see they've got relatively close elevations. If I look at my coordinates, I see I'm at 76.509.0. So probably the same thing, 76.509.1. So there's slight differences. So at this point, we need to do this comparison between these 2 points, okay? So if you want to just simply find out the bearing and distance between those 2 points, that is an inverse. So I'll go to my Kogo menu and run inverse, or I can simply just type the letter I. All of these things in the parentheses to the right that you see in the menus, I can just type that. So if I say now it's an inverse and it says above, calculate the bearing and distance from starting point. So I need to pick a point or a point number. So because I've separated these out, I can actually pick that point. And if I turn my point object snapping on as I hover over these little descriptions, I don't have to type out these point names. So I'm going to go from J1 up to J2. And I see down below here, let's open this up a little bit. There's my J1 to J2. You can see the slightly different coordinate values. And it tells me that I have this bearing and this slope distance, this horizontal distance, and that vertical difference. Okay, now I also see, I'm going to finish that command up here. And I'm going to run my units command to take it from 2 decimal points. I'm going to run this up to say 4 so I could see a little bit closer, a little further down. Now I'm going to go I for inversing again, and I'll just pick that one and that one. And now you see a little bit further out in the coordinate values, and it tells me that that is at a bearing of 87 degrees or north 870815 east, and there's my slope versus horizontal distance. Okay. And if I were to keep going here, I could say, up to the next one and then on to this one. So you can see these that it's picking out here. Now this is not as it's not helping me to find out the differences in those 2 particular points. But, as soon as I enter the inverse command, if I say as soon as I pick any given point, so there's that CA 9134.1 up here to CA 9134.2. Okay, so I look down here on my command line, there's my CA 9134.1. There's my 0.2. And you can see, what my differences are. Okay. Now, you said you had a problem that it wasn't calculating correctly?
Excuse me, Ken, that basically was to the bottom, right? But to get that list, what was just displayed, that difference, where would we go?
Well, that's what I'm saying. You could type the letter I, or that's this Kogo menu, inverse. And that's all I did is I typed I. Now, one thing to help me so that I don't have to type all these long point names.
Hey, Ken,
Yeah.
Taking off.
man, this is a situation that we have. Those points, right? There's a command that you have on the points that says point comparison, right? It's supposed to can give you a comparison between all the points that are relatively close by, and tolerance as an offset. I can't remember exactly what it says in that. If you go to your point command,
You mean on my points menu here?
right, and go all the way down to the bottom where it says the utility, it says point comparison or something. Yeah, I'm a bit away from the screen.
This one right here?
Compare points.
Compare points, right?
Yeah. But what we have to do there, I think, is typically, we tell it so our source points to compare, they're
Right.
either come from the drawing or from this coordinate file or another coordinate file. Okay, so let's just look at them, say, from the drawing for a minute, or maybe even in this coordinate file. All right, and now I'm going to look at my delta x, delta y.
That's what we need, the delta x and delta y, and then the horizontal tolerance will be like maybe 0.15.
Yeah, so let's say let's just make them, a tenth, but everything's probably well within a tenth, I'm going to guess.
Right.
And so if I say okay, then I'm going to say all. Just so I don't want to have to type out all those point names. And now I'm picking up my the points to group. So I'm going to say match these by my tolerance. So within, let's say, like half a foot even. So that will certainly, so I've got 12 matches. And delta north, east elevation. Let's also get the point numbers. Okay, so this gives me this result.
Yeah, but you see, Ken, it doesn't work like that tonight. I think there's a bug in it somewhere. When you try to do that, I'm not sure if it tries to pick the points from a clockwise or from the highest coordinate, and then you will find at times the difference in the delta eastern and the delta northern is maybe like a 100. Why it's not 100?
Yeah, I mean, if that could be, see, that could be that tolerance value that we put in there. So if we're looking at this, my CMAG is looking at CMAG 2, CMAG 2 is looking at CMAG 3. So this is where I've got these points. And so now I do not have a comparison here between CMAG and CMAG 3. I've only got CMAG to 2 and then 2 to 3. Then I've got this next one, 0.1 to 0.2 and 0.1 to 0.2. Actually, that's a different point altogether, like that. And then my IPC, my find 1, found 2. So it's the original to 1, 1 to 2, and 2 to 3. It's not like I could say, look at 1 compared to this, and 1 compared to that, and 1 compared to this, and then go to the next point. This is just picking up pairs based on this value,
Okay.
yeah.
What we require for our reports is a direct comparison between fix 1 and the datum, fix 1, fix 2, fix 2, fix 3. So we need to be able to tell it what to compare.
Okay, so instead of having it pick these,
Yeah, we need to be able to tell it to compare this to this. Is there a
well,
generate report?
yeah, I mean, you'd have to, there's a couple of things that we can do with that. So we could use this range of points, etc. I'm not sure that is going to be our easiest solution. However, if we have, and you can do these by groups, I would imagine, if we set these group names up. But here's one way to do this. Is a completely different,
Ken,
yeah.
what you just showed us, is it? Because the first point you've compared it with the first fix, which is the data. Then the second one you've compared with the first fix with the datum, the second fix with the datum, then the first fix with the second fix. From that document just computed right now.
Okay, so
The point comparison.
yeah, so if we run that,
Just go back, we check again.
okay, so and check that. Let's just report points missing. Let's see, DMS. Let's put that back on. All right, so it's actually doing this one. It says compare points. It's comparing 1.2.
If, for instance, like your job, you go out to your theoretical function.
Yeah, I'm having a real difficult time. Some of your microphones are real echoey. So I'm having a real difficult time hearing what you're saying a little bit here, but maybe we can step through this. If I look at these pairs, let me see if I do all pairs. Now this may be what you may have done. I've got my base range, my target range. It's matched by description. No actual, okay, so we say okay. So first and seconds, my deltas. And let's look at those. Those are basically the same thing. So mag to mag 2, mag 2 to mag 3, dot 1 to dot 2, dot 1 to dot 2, find to find 1, find to find 1, find 1 to find 2, find 2 to find 3. See, there's nothing in, say, this group of points that looks at, see, that looks at the unsubscripted.
Ken,
So see, it's just when, if I'm trying to do this automatically, it's not finding all of the total pairings. It's only doing them in order as it finds them.
Ken, let me just explain something. I think I understand what they're looking for.
Okay.
So just go back to that, what you're just showing right now. Just go back to it. Yeah, now you see, for example, the IPC.
Yeah,
The
right.
LIPC.
And then this L.
Yeah, so LIPC is basically like the data. So they did the first fix, which is LIPC1. Then they did another one, LIPC2. Then another one, LIPC3. So what they want is with LIPC, it compares with 1, 2, 3.
Yes.
So we don't have so it should be LIPC with LIPC1, then LIPC with LIPC2, then LIPC with LIPC3. Then with that report, now they can see how the 3 fixes compares to the data.
Right, but you also then want to go back to your, are these the datum points here?
No, this is another point as well.
Oh,
The
okay.
IPC
It's just
yeah.
the ones that does not have the decimals. That's the datum.
Yes.
Okay, so yeah, and that's exactly what I was saying here is that what this does right now, if I wanted a way to do this automatically, I'm not sure that I can do that because it's just finding them in order. So that's what it's looking at, the datum to the 0.1, and then it goes up to 0.1, it goes to 0.2, and then 0.2 to 0.3. But I need to be able to see my datum compared to 0.2 and my datum compared to 0.3.
Exactly.
Okay, and I don't really need this 1 to 2 and 2 to 3. I just need this held and these other two done. So that particular command doesn't do that unless I can do this. I can say again.
Okay, I've been experimenting with this for a couple of months now.
Okay.
And I tried to put like all the first fixes in one group, all the second fixes in one group, and all the datum points in one group.
Yeah.
And then here, where I have base range of points, I would select the datum group.
And then the target range, you would set
And then
those
the
up.
target range, I would put fix 1 or the first group, the group of points with the first fix. And then I'd try to do the report with that. But then
Okay.
it still compares all the points in the drawing. not just those in the group.
Okay, all right, let's take a look at that and see. So I'm gonna go to my points group and I'm going to make a group called datum.
Right.
And I'm going to do that by including all, but I'm going to exclude .1. Anything that ends with a .1 and anything that ends with a .2.
Right.
And did we have any others like a .3?
Yeah, and that's right.
Yeah, all right. So if I save that, here's all my datum points and I've got,
Wait, you see, you still have that ones and that twos in that datum group.
okay. Here's why. Because I say excludes by description. It's not by description. That's
Okay.
not the description, it's by points. Okay, now, how to do that? See, really what you've got named as your point names should probably have those as your descriptions in which this would work. But so now I can either do this manually or if I,
All right. Use the description filter and use 717. Because 717 is the first fix.
oh, okay, then that would
So
work.
you could have a group name first fix and
Okay,
filter by 717.
all right, so right now I'm gonna make the datum. So the datum,
Is everything without 717 or 718.
okay. So I'm gonna say 717 and 718. So now I've got 750, those are
Oh,
codes.
exclude 752.
All right, but
750 is a third fix.
okay. So this is still not going to work exactly. I'll show you why. You see this? There's J1, J.1, J.2, and the description says IPC. And it got rid of everything else. See, what is a datum point, for instance? Here's a datum point, and it also has a code of 717 in a description.
Ken,
Yeah,
I'm trying to, okay, we're discussing here, there's another option we're looking at. Is it possible to select the datum points and then tell it to compare with points within a certain tolerance from it?
yeah, but see, part of this is complicated by using those, what you really should be using as descriptions, like these CA 9129.1.2. Those really should be your descriptions and not your point numbers. This 717 and 718, the 718 looks like it works for the .2s and the 717 works for the .1s, but they also are working for the plain old undotted numbers. Like, see this? This is your datum point, your F and D compared to this first fix, but it has a code of 717. So that's not exactly, here's a .2 that's a 750. Here's a .3 that's a 750. And here's this is your data point that's a 717. Here's your first fix as 718. So these things are a little bit miscoded. And I've got some things. Where did everything go? Here, let's see. Let me find a point.
Ken,
Yeah. I've lost all my points. I don't know where they got, they're here, they're in my file, but
Ken,
yep,
let, can you try something like this? Let's say we have the data points, let's say IPC, and then tell it to compare with any point within, let's say 0.5 of a foot from it.
right,
You see what it gives us in terms of the results, whether it is going to compare IPC with all the points that are within a foot from, or a
okay,
0.5 of
right.
a foot from it. If we can get a report for something like that, then we can see maybe what to eliminate from that.
Okay, so let's go to back to this particular point. I'm gonna find a point by number, it's gonna be J.2. Where did they? They just disappeared on me. I didn't know where they got to. Okay, so if we had a point, let's say we've got a small enough file that we can do this. We could say our point groups manager for datum. I'm going to include that. I'm going to say this. I'm going to include all. And I'm going to see what this does. I'm going to look at, oh shit, I still can't do this. I've got a CMAG. Let me, instead of including all, let me just select from this list. I've got this one. And I've got this one.
Ken,
Yeah,
if I send you a file with the datum values for these points, would that help?
not necessarily. I just needed a way to be able to tell it which ones to use. So
Because
now,
I have a file with the datum, because all right, these points here, we had datum values for them, and then we went to look for them on the ground in the field.
okay,
So we have a file with the datum values. So when we go out there, we're looking for those values,
right,
searching for the boundary marks.
right,
But
understood
if
that.
we find a boundary mark, we observe it twice. So where you see we have like J.2 and J.1.
Yeah,
Using the data value, we found the datum value, we found J,
yeah,
and we observe it twice, which would be J.1 and J.2.
okay. Now,
So in this, so this file that you have now doesn't have the datum values in it. It just has the observations from the field.
all right, so it's got J1 and 2, but what about this? What about these right here? The C mag, is that not, that's a 1? Really should, that
Yeah,
should be,
that should be C mag that one. Because you see you
okay.
have that 2, that 3.
And then these F and D should be .1 and .2, right?
Yeah, right.
But maybe after.
We still to know how to do it.
So if you
Yeah.
want, I could send you the actual datum file that we use to search for these points. And then you
Okay,
could use that as the basis of comparison.
yeah, that's fine.
Percy,
Yeah.
this not sounding like Jerry, man. A value is a value, man. We just need, you just need to compare it to something, then you can practice it. You don't need a file right now. Just, let's know how the software operates.
Right, right. So you can say that one is the datum and compare that 2 was first fit.
Yeah, I mean, I need to have that value that I'm going to use to compare it with.
All right, I'll send you the file.
Okay, go ahead and send me that. Now let me, and you see what I'm getting at is if I make that group as my datum group, then I can compare those with these others as by using group names. Okay. So let's see. There are a couple of other ways that we can do this as well. I'm going to show you that's completely outside of this command, and it really gives us a lot of information. I'll show you that in a minute. But let me verify and see when I get this email. Of course, it'll take a minute before all of the computer systems on your end and my end decide that there's no viruses before it'll let it go. So we'll wait on that here in a minute. All right, while we're waiting on those points, I'm going to go back to this group manager, and I actually will make that group. We'll do that when we bring this imported thing in a minute. So yeah, this process might work a little bit more straightforward.
Yeah.
Yes.
As we wait for the data, I just want you to try something for us. Is it possible you can take maybe like the LIPC and then compare it with LIPC1, LIPC2, and LIPC3?
Yes.
Yeah, sure.
Could you just check that for us as we wait for the data?
Yeah.
Okay.
So if we go to this, and this one will tell you it's completely outside of that particular comparison command. And let me show you this one. This is called a deed correlation. And I'm just going to make a new file called point pt-comp. So point comparison. Make it so you can see this -comp. All right, so I'm going to basically say, I'm going to compare survey points and deed points. So I'm going to make these point pairings. So I'm going to go to from survey to deed or deed to survey. That we'll use it that way. So I'm going to now add a point. So my survey point or my deed point, let's say, now which ones were you saying that we wanted to look at? The
IPC,
Yeah.
the last four.
these here.
Yeah.
So, all right, so there's my deed point, right? LPC.
Yeah.
And then for my survey points, I'm going to come down here and get this one, the LPC 1. All right, so that's 1. And I'm going to now add this other. So this was again IPC. And this one was IPC.2. Oh, wait a minute. It's not the L part. Or was, yes, it was. Sorry.
Yeah, LIPC compared with LIPC2.
Yeah, it was, it's LIPC. So this is the one that I should have fixed. So L underscore, and then L underscore. There we go. And I will add again, let me just get rid of that little thing here. So L underscore IPC to L IPC dot 3, and then add again. Did we have another one?
No, that's it. Those are
Okay.
the 3.
All right. So if I so I'm looking at IPC compared to 1, 2, and 3. All right. Now I'll go ahead and save that. That's a listing of pairings that I can use. And now I've got these buttons down here that are going to say, give me an inverse report. And you're going to see that now shows as survey points to deed points. So from LPC2 to LPC, or to IPC, from IPC2 to IPC, from IPC3 to IPC, from IPC1 to IPC, okay? So that gives us each one of those individually. And if I look at the compare before align, this is going to also show me that same set of comparisons. Everything pulled back to IPC, looking at 1, 2, and 3. Okay, so there's your individual distance, your individual deltas, and bearings. But it's all compared to that one single point, right? So that's one way.
Do I use the point comparison?
But when he comes to this.
Yeah, that command is actually under survey, deed tools, deed correlation.
From survey, did tools then did correlation.
Right. Now, where is my, that's these points right here, right? Yes.
Yeah.
Okay. All right. So now there's even further that we can do is under our COGO menu, coordinate geometry. We're going to do a best fit point. And we can select our points from the screen by a group or by point number. I'm just going to say by the screen. And I'm just going to grab these points around that cluster, okay? So I'll say enter to finish that selection. And now here's what I've got. I've got an LPC and an LPC 1, 2, and 3. Now these are all computing around, and it's comparing it to, you see up there above that average point in this line above, the second line. That's the average of all of those point locations. And it is comparing or showing me the residuals between any of those points that I've selected to that average point. Now that doesn't, see, this is a little bit different because it doesn't let me hold that point, like holding the IPC and then comparing these others. This is just, this is sort of a cluster analysis of those points. Now there's another possible way. If this will work. I'm not sure. I was thinking about it over our break. If again, go to my best fit, and if I do this, see, it needs to be a best fit line. That's why I didn't think it's going to necessarily work. If let me see a best fit circle. This might even work. I do a 2D, select points from the screen group. All right, so from the screen. Pick the design center point or enter the point number. So the design center point is going to be this IPC. All right, so if I draw the circle, I don't need to draw it. I'm just going to create it. So now it is comparing the center of the circle. Oh, wait, I know how to do this better. Let's take this LPC out of the processing mix because that was, I should have, instead of taking all of those points, I should have just taken these 3 points here. And that's going to then let me choose that circle point. In fact, let's back up and do it over again. If I repeat a best fit circle, it can just be 2D. I'm going to select them from the screen. And I'm going to select LPC 1, 2, or IPC rather, not LPC, 3. And those are the 3 points I'm going to check how well they're going to fit. Now, a design center point or a point number, that's going to be now my LIPC. That's the one I'm trying to hold. So it's holding. And if I store that radius, well, let's see, this is not exactly right either. This is computing a circle through these 3 points, which was, that's why there's no residuals. But it has a center point that could be different from the IPC point. So that still doesn't give us that, what we're looking for. I was trying to see if we could, we still might be able to best fit circle my screen. Let's look at all 4 of them and then use that as a center point. So that still gives me a bit of residuals, but it's not, See, that's everything within a radius of 3/100ths. If I say, okay. It's really not going to give me much. Let's see, there's my,
Just say it.
Yeah.
10.
yes,
Your previous screen, but yes, this place, they're available. No, please, the available settings, their report formats available. You
on
don't
the,
have any of them.
on the report.
Yeah.
So Ken, if you should look at your, even we had the point compare point screen, and you can select it to compare between the Delta East and Delta Northern's point number and point elevation.
Yeah,
We
so,
don't, we don't have a setting for that.
right, you don't on this reporting, you're talking about right here when it comes up.
Right
There's,
here,
Yeah,
right,
you don't have any
right.
of them.
So you'll have to find a way where you can maybe import it.
yeah, so that particular command is not really one to go. See, what that's trying to do is it's trying to create a circle that these points define the closest. So if you, let's take a quick peek.
Before you go further, we're talking about the very first screen where it goes, where you on the point. If you go to follow me on it, I'll put you where I'm talking. It goes to point, go back to your point menu. And come all the way down to convert format.
We don't want to convert, we want to do this.
Point utilities and then compare points.
Yeah.
Yeah,
And if you try to compare the points there, and if you should go use report format, I go okay, yeah, right, go okay now. Or go all again, if you want to do all, whatever you need to do there.
well, if I say, oh, I mean,
Yeah, we just showing you what we're missing. We don't really want the exact results.
I mean, I know
Yeah.
what, yeah. And so if we go
All,
off of those,
and go okay. There, we don't have, inside over there, it comes in blank. It comes up blank, so we can't do anything from there. And that's where I think we're missing a
let's see.
couple steps. We don't get anything in there.
Yeah, but him not having it, him not needing his one.
No,
right here for now.
but the first one, yeah, so I don't know why.
So it's not,
Because on your first test, you had it, right?
well, yeah, but the first time I did that, I didn't use that. I didn't use this report formatter.
What did you use?
I did not use the report formatter. I just unchecked it.
Okay,
Uh,
go ahead, let me see then.
Yeah, so all to all, and I say,
Okay.
okay, now you see, it gives me everything's within a tolerance, but if I give, all my northern easting is tolerance, let's say 0.001. 0.001, I don't, everything, so here's what I triggers it is, let me just call it 0.5, is that I'm comparing, I said all to all, even if I use the report formatter. The difference I've got right here is if I check this. If I look for all pairs and I say, okay, so here's my base range is going to be all points and my target range, and that could be whatever it happens to be, but I can say match by description or by tolerance. So if I said by tolerance, I'm going to say, oh, just like every foot within, so that it doesn't, it's not trying to match the IPCs here with all of that, like J1, J2, that kind of stuff. So now that I've done that, it's put 13 matches in here. And now I'm going to say, okay, and now I've got these available. Okay, it didn't generate those. That's why you had them empty when you just say all to all, because it didn't have anything to calculate that stuff with. It now, when it found the information and it generated those pairs, and if I look at that command again and just see the pairings, this business right here, these compared to these, that's what made it calculate those and come up with those individual pieces.
That's actually what they're looking for.
Yeah, these are the things. That's what made these available. If I just do this by
So maybe Ken, you could repeat that step properly so that they could see how to go about it.
yeah, that's what I'm saying. So if I just run this and instead of, let's just go back to what we had the first time, we said all. If I can type AL,
I'm trying to get the demo, James. He's
Okay.
trying to get the because you remember when he did it the first time.
yeah, so here's what happens here is
Now showing how to go about
looking at
it.
base range of all, and I'm looking at a target range of all.
Doing what we were doing, then what is going to happen.
If I say, okay, yeah,
Right. That's what we're missing, Ken.
Yeah, all right, so I say all, I'm gonna turn this off here. All to all, and say, okay, so that's when it comes back to this. Okay, because when I'm running this command, and if I do not check to compare all pairs, then it's not looking at that list. It's just taking a list of, when I go to the next, all points and comparing them to all points. So it's looking at those all, you know, 1 point compares itself to itself. So I don't have anything in that particular group. That's where I have to make these matches either by description or by tolerance. Okay, so if I do it by a tolerance at, you know, just 5 feet, I now have 13 matches. So I've got C mag in my base, and in my comparison, I've got C mag dot 2, and up here I've got C mag dot 2, and I'm also looking at C mag dot 3. Okay, so I could, you know, edit all of these different things or find some way of getting a group of my points to be able to then do this. And now that I've got some things to compare against each other that are different, it gives me these to choose out of that list. Okay, and then I can, you know, even look at it and put it in a spreadsheet and do, you know, whatever else that I might want to do. I've got my, I can look at totals, or the first point, the second point, deltas, or, you know, however that may work out to be. And then display. Now, what did I miss? So we're looking at CMAG to CMAG2 and IPC3 to IPC4. Oh, because I did not compare these coordinate pairs. If I said all comparisons, then I'm going to get all of these. And they're going to show up. You know, I could kick them out into a spreadsheet. All my deltas, northern eastern elevations, etc. But again, this is CMAG to 2, and then it's 2 to 3, but I want to also make sure I can do MAG to 3, or even to some other known point. And the best command that I've found that can summarize all that for you together is that deed correlation point file. So if I go to my survey, and understand it's generally meant for deeds, but it's a good tool to do some correlation with. I'll make this new one. And I'm going to go, let's go survey to deed maybe. In our survey point, I'm going to simply add a point. And I'm going to find this IPC. And I'm going to use IPC1. I'm going to now add another one. I'll just repeat those as L IPC. Let me copy that. IPC.2. .3. Okay, so now I've got those, and I'm looking at those. So 3, 2, and 1 compared to the original here. I'll do my inverse report. So here's my survey points. That's the ones I'm holding here because of the way I've set them up. I've got IPC. So IPC is going to look at deed points, IPC 3, 2, and 1. And so you can see right here, I've got what do we have? There's my bearing and distance right here over to these points. And that's why, you know, these are like due east with zero distance because it's looking at itself to itself is what it's doing there. But so I'm looking at this compared to 1 and 2, this compared to 1 and 3, and this compared to 2 and 3, that it's, you know, comparing those differentials. If I say need to survey, do my inverse report, it's doing the same. 2, 1, 3, 1, and 3, 2, all compared back to this original point as well. And once it's done, if I choose a
Yeah, that one. Compare, yeah.
pair, then this is really what
Yeah, but you want to do them, is I would tell you that.
this is what you were asking to have done is I'm looking at this one point, comparing it to all of these other 3 points, and that's how they fit, either good or bad. So 1 is the best, 2 is a little worse, 3 is a little better than that one. They're still not bad for any of them. But you can see in this case, LPC or LIPC compared to LIPC.1 is the best fit.
Yeah. Now, Ken, is it possible now to do like a chunk of it, a big number? I'm all,
To do what?
let's say, for example, I have the IPC as the data point. Now, if I have like multiple points that have more than one fix, can I do a big number, or I have to do it one by one? Like the way we are doing it right now.
Can you put together your point list from that? Is what
Yeah.
you're
Yeah, so this means I need to go to the screen and select each one by one as we go.
right. I understand your question, and I don't know the exact answer to this other than let me look at this. If I add a point, use the screen pick or fill out the dialog, which I don't want to do, add a polyline. This selects the polyline for the survey indeed perimeters and uses the vertices for the survey indeed points. Yeah, that's not really going to be helpful in that regard. I was hoping when it said add by polyline that it would let me pick within a distance. So that does not. If, however, if I'm looking at my best fit point, I can do that by group. That would be helpful. I can do it by the screen. And it wants to know, see if I take every, all right, this would, I would have to be able to do this by grouping. Right now I can't. I can't pick these because they're all together. I have to pick these. So I'm gonna do a best fit point with these out here. Not this one, because that's the one I'm concerned about matching. So it's going to make a point here that is the average point between those 3 locations is this. I can output that. I'm going to call that back to 4 again. And now see, that still doesn't.
Then,
Yeah, yes, that doesn't, that what I'm trying to do here still does not give me.
Can inform you on
No,
which.
at least,
Which
Ken,
ones we just
the
use
good
in
thing,
the
at least we've seen one way of going about it, using the did.
Because
So
what you
we can,
at least.
we can basically work with that. Then maybe we can proceed with the other questions. Then if we
Okay.
get time, we can come back again and deal with this.
Okay, yeah, I will, So I've got another note I took here, says calculate offsets. I can't,
You can find a solution later on, then email us maybe a PDF or something.
yeah,
Okay,
I've got, we can calculate how far these points lie off of an alignment, off of a linear feature, but not off of it, not how much they differentiate between a known value. Other than that inverse report or point compare. So, all right, I'll put some thought into that. I may even have to call up Carlson, and it might be something that Carlson just says, never really thought about that. This is a new command, and it'd be simple enough to compare it. So maybe that's the case. We don't know, but I'll do that. We'll take it from there. Okay. So now,
let's proceed with the other question.
yes. Okay. So that was our, let's see, best fit point, also decorrelation. Okay, so we've done that one and, okay, the collinearity, that one I can do. So annotate, compute. All right, we talked about the annotate command, and compute the bearings and distances. Is that basically what we were looking at with this, or do you mean like between, if you had like several points, like if I did an inverse between this F find and this 3767.1, and I see that is my, three, four, let's make it easier. Let's draw a line between this point to this point. So I've got that as a line, and if I go to annotate, and if I choose this either automatically annotate, or I want to get my bearing and distance, I'm going to get my bearing alongside of my distance, and I'll pick this. And so were you saying that you would sometimes calculate the difference between these two and you would not get those same numbers? Anybody?
Jerry's on it. Oh, okay.
Jerry,
Somebody was looking at, wanting to know that what with the annotation.
Yeah, would you be able to draw the line from C well, in the line, I mean, I'm using C to D, because basically when I will list it, I get like baseline 92 degrees and minutes. But when I would actually draw the line now and annotate that line, is giving me like shy of 88 degrees.
Okay, so I've drawn this line in here. Now I drew it as a polyline. So, but you see that distance 345.63. So that matches my properties of my distance. I don't see the angle because it's a polyline in my properties, but if I were to make that a line, I would. So I'm going to change that from a polyline to being a line. And now if I annotate, in fact, let me change that. If I select this, let's draw a line, not a 2D line, but a line. So just simply draw a 3D line from here to here. Now it's prompting for that elevation. I'll accept that elevation. I'm going to go up to this one and accept that elevation. Now this may be what's going on. So if I annotate that, that was my bearing and distance. Let's put that, that's bearing over distance. There's bearing and distance. So if I do that, okay. But then if I select this and look at my properties, I see that I've got an angle of north 57, 34, 50 east, or that worked, and a length of 345.63. That, well, they happen to match at this point. If I'm just looking at those things. Now, my guess is when you've got some that are showing up differently, Are you making sure, because when you do your annotation from this annotate menu, those are always horizontal distances, even if this is a three-dimensional line. Okay, so it's as if you're putting deed calls on a property boundary, which has, you know, there's no consideration of elevation on those at all. So I'm guessing that might be what's been the issue. If I compute as an inverse and I go from that point to that point, I see down at my bearing, there's that north 57, 34, 50 east, that works. I've got a slope distance of 345.64, but a horizontal distance of 345.63. Okay, that's why that's showing up like that. Now, do you have anything at all like over here that might illustrate what you're talking about in that file, or does I'm having a I'm not understanding exactly where you're getting those as being incorrect, unless there's just something about it. Is this something that happens all the time, or is it just like you noticed it once on a drawing somewhere?
I noticed it between C to D, and it happened several times. I've done now the same one you're doing, and when I annotate that line after BB 3767, it actually shows me the same. I mean, that's working. But strange as it was Tuesday, and then yesterday, this morning, I kept drawing that line between C to D, and when I would do a list, it would give me like 92 degrees, which I know is the correct bearing, but when I would actually annotate the actual line now, it was saying like 87, nearly 88 degrees, but again now, after BB 3767 is working.
Okay, so it seems to be working now, you're saying, so. And it was basically the bearing that was off? You said it was like some, like 88 degrees or something? I mean, it could be that we had you know, maybe you were in a user coordinate system that was rotated. When you said you drew a line between C and D, I don't know what you mean by that. Is that a point, you know, do you have a point number called C and one called D or something somewhere that I don't have?
No, it's basically the same points there. I just call them C and D because I know that's their true names. Person did this field file, so he put on like IPC fix one or dot one, but I know them as C and D. That's why I'm just speaking it out as what they are.
Okay,
But
yeah.
I'm clicking on the same points like you were done now for the F and D and BB 3767.1. It's just a difference of a minute or so, between the fix and the original or the first one. But no, it was happening a lot with C to D. I actually want to try it again because I did it up to about 10 minutes ago and it was still listing the bearing I started as 92. But when I would draw the line between the 2 points and annotate the line, it was giving me 87. So, like I say, my software from last year didn't register properly. Before the course, we tried to got it reloaded, and it still said unregistered. Up to Tuesday, it was still saying unregistered. So miracles do happen, but unfortunately, I hope after we're done today, I don't find this problem occurring tomorrow or next day. Because I mean, something's going on.
Yeah, well, be sure if you keep running into that you can let me know and maybe give me, maybe save the drawing and the coordinate file both and let me know what they are, and then maybe we can get them emailed to me, and I can do some investigation on it. But as far as I know, this is the only thing I was thinking, that you could have been mistaking a slope distance for a horizontal. Or
No, it's based on the bearing. The distance was coming out just about the same, 0.03 maybe. that was the bearing difference of about 4 degrees.
All right, so when you drew the line, how did,
See,
how
to-
did you,
to-
like,
yeah.
when you said draw the line from C to D,
draw a
Did-
line 2D, and then I picked the center, and I created a line between the 2 points.
all right, so do you have, what does your point symbol look like?
It's a circle.
Okay, so I'm just wondering if you zoom in really tight. Let me change that to a circle. If you've,
Three points in there.
so if you zoom in really tight, can you tell whether that line actually goes exactly to the center of that circle? Or could you have, you see how the circles are in slightly different positions. Could you maybe have, and you say you snapped to the node or you snapped to the center of a circle or something?
So the center,
Yeah, I mean, the easiest way to combat that, because what can happen a lot of times is if you have something like that and there's these X symbols, is if you have a snap in place, like an endpoint snap, that it's gonna, miss, it's gonna go to the end of that drawn symbol and not the actual point location. Now, the other thing is too, is back here is I've got this dot one and I've got this datum. So there are actually 2 circles there. And if I just go to the center, I have to make sure I'm using the proper circle because I don't know which circle I'm going to. And I can look at this by zooming in, this dot one. You see, it lives at the end of this arrowhead, whereas the one that I drew between is out here where this line that comes in from the side, you can see how they miss by a certain distance. That's that difference between the datum and the dot one. So just making sure that you are on the exact right point when you do that. Now, the easiest way that I found to do that is when I separate out these attributes, is I make sure on my settings menu, I have this point object snapping on and off. And then when I draw my lines, I can just point to the attribute. So I know when I point to this attribute, it's going to be that specific point and not this point, even though they're right on top of each other as far as the point locations. So for instance, if I draw, if I want to draw from there, if I were to hover my mouse, let's see, make sure that my settings is turned on for that. It's now on. So now if I hover over that F_FND.1 or any of those attributes for that point, and you can see it's lighting this up down here in the center, but the one it's grabbing is the 0.1 point location. If I'm over here and I point to this, any of these attributes, it's going to grab the not 0.1, the F_FND without the 0.1 on it. So just make very certain when you're doing that, that you are drawing it from the right point to the right point. And you may be, like you said, you call them C and D because you know what they are. And so that could be the same. So if you run into that again, try to get me that data set and the points and explain to you what they've meant. And you can work on that stuff through James or through Darren or whoever else, or you can get in touch directly, however you'd like to do it. Okay. But that should be, all of that stuff should be consistent when that happens. Cause these annotations will not, I mean, when it's doing that, and I did that bearing distance and, I picked that line to draw it, then it's going to actually, go to that exact endpoint. So wherever that endpoint happens to be is where that's going to get computed. Now you can also do that. You don't have to have the line drawn. Okay, so you could simply not have anything drawn at all, and you could say annotate that angle distance. Here's my bearing and distance. So down below, you see I've got two different choices here, one for size, one for point. If I say, see, it says select a line or a polyline, or if I say points, it says, oh, okay, pick a first point or a point number. So I'm going to now grab this point. I'm hovering over the attribute. I'll click, and it wants to know the second point or point number. I'll hover over that attribute and say click, and there it is. Okay, so it just puts the text there as if the line were drawn. So just so you're aware that there are several ways to do that annotation. Okay. All right, so let's look at some of these area checks. So if we're talking about your area computations, what is it that you are doing or using? Let's say if let me see if I can freeze some of this off of here. All right, do we have any, don't have any boundaries really? This is. All right, that's probably not a real good file to try to look at area checks. You're talking about probably like a, like the area of a deed or a parcel. Is that what we're looking at?
Yes, Ken.
Yeah.
There was a boundary, which
So trying to bring back.
And so if we've got, all right, so when you're doing these area checks that you're looking at, exactly what is it what is that you're trying to compute? Where are you using your commands? Tell me what you're doing, and so I can see what we're looking to do. You know, is it a map check kind of thing by points or by screen entities? So if I did a map check, let's say by points, we've got by these distance and a precision. Might as well go up to say 3 decimals. And let's say if I went from, say that, now it's gonna ask, it's actually looking for a point number, point name. So this will basically report to us the closure of a figure, usually a parcel. Doesn't have to be, it could just be a check. Is that what you're talking about doing with the area calcs?
yeah.
Okay. All right, so let's do a couple of things with that. I'm going to just close this off. I'm going to start a new file. And I'll just take the old Carlson default here, say finish up. I'll give it a name, and the name, I'm going to make sure I'm in my data sets folder, and I'm going to call this one area calcs. as my drawing file name. And I'll say next, and I'm going to use a new coordinate file. I'll take the suggested name and I'll say no import and I'll say next. Okay, so now I have a drawing file created. It's empty, there's nothing in it. So I'm going to go to a particular place. Let me see if there is something for us to load up. Yeah, here we go. All right, so if you go to the survey menu for a minute. Now, you wouldn't normally have these things, but I happen to have some in your data set, so it'll help us draw these things pretty quickly. Let's look at the process deed file. So if I choose that, and this is going to be one of these two files, we're going to look at them each individually here. I'm going to look at this enter deed. I'm going to say open. And there's that lot 1 that's in it. I'm going to edit that. And this is what this looks like. Now, this happens to be in your book as a further example, as if you are actually creating this as a deed file. And you can see that it has, let me switch that to 3-column degree. So it has distances. It's got lines and arcs. I've got distances, and I've got the quadrant, whether it's a northeast, southeast, etc. And then the bearing. And for my arc, I've got a arc length and a radius, etc. And if I, simply sit in those particular items, you can see where it happens to be. So I get around to this last item. Now, notice the distances in my spreadsheet here, or in your spreadsheet as well, under the feet of the distance feet column. That distances are to like the nearest, ignore the arc distance because that's a computed number. But if you look at the arc length and the radius, you see that's a 175.0 and a 200.00. The arc distance that you see, that's the chord between the PC and the PT of that arc that it computes. But all of those other distances are just to the nearest hundredth. They're not real, ultra precise. Those would be, and this file was actually created by typing in the numbers that we read in a deed. We had this bearing and this distance. And we started up here at this very first line right here. And we said go 165.45 feet along a bearing of north 25, 30, 45 east to set the next point. We get to that point and we go to this point and it said to go south 45,0000 east, a distance of 200 feet. It computes the point there. You get the idea. We work our way all the way around and we get to this last line, and that should take us back theoretically to the beginning. It didn't quite get there. There's a little bit of misclosure. Okay, and that's what we're trying to calculate here. So I'm going to say okay to this. I've done the just to edit. So we've seen what we've got here. Now I'm going to, we could use this tool to report our closure. We'll say okay. And it tells us the lot number, the starting coordinates. There's our deed calls that we had typed in. And by the time we get back around to the ending, which should have been the same as the beginning, it wasn't exactly that. It was a misclosure of 1 in 84,000, I had a distance of 0.01 along that bearing, and yet it still, and it calculated my perimeter and my area within that as a closed figure. Okay, but it also computed the misclosure, which is what I was after. I'm going to go ahead and select that lot 1, and I'm going to say draw. And it's going to, I'll just tell it to draw as it's doing there. It's now done. I will exit that. No need to save that. I will now zoom extents, and I will see this indeed is the result of that deed file. Okay, now you could have put these in simply by doing draw 2D polyline. You could come over here and you could have said, all right, I'm going to go a distance of, what was that, 165.45. And I'm going to use it by the angle method, and it's going to be the northeast at 25, 30, 45. Okay, and then I'm going to go another distance of 200. And it's a southeast bearing, so my angle would be the code number 2, and it's going to be 45 degrees. Okay, so now you can see, I'll go ahead and finish this. You can see that this is this. This is what I'm doing to build that around through space. So I don't have to have a deed file. I could simply draw these things around. And when I get to the end of this, and let me go ahead and change this color just so you can see it a little better when we zoom in to this. And I'm going to take that particular description off. And if I look at this and I zoom way in tight, you see down here below is the point I started, and this point up here above is where I ended. So it did, even though my deed, and that was in fact an actual deed that was coded in, but by the time we come back around, we miss it by this amount. Okay, and that amount, if I do an inverse, and if I pick from here to here, you see that is a bearing of south 23, 25, 21 west of 0.011 distance. Okay. That was the very same thing that we saw when we did the process deed file, enter deed. We gave the report. Sorry. Report. This is okay. There it is. No, something's. We have to go into this editor first. Let me see. I don't think so. Huh. I see what it is. Is that this last leg. Should have been my closure. There's my first leg. There's my last leg. That should have worked. Say, okay, let me save. There's this last closure, but it's telling me that my total perimeter is 98.6 and that my closing error distance happens to be exactly the same as that, which is not correct. I don't know what's happened to it. Let's see. Three column. Line to line to line to line to curve, rather. To line to line. That's all fine. That's exactly what it needs to be.
Hello, Ken.
Yes.
Ken, can you kindly focus on how we can generate the area and the area reports, right, for these ones? Because often, because we don't use the total stations, we often get a closed polygon and we just need to represent the areas on it. So for this one, we want to know how to generate a report for it. And in some cases too, sometimes we will have to calculate the areas for adjacent parcels.
Okay.
So it's actually sometimes it's a multiple parcel and not just one parcel, because sometimes maybe there is a road going through series of parcels, and then we'll have to calculate the main road which we've taken, and then the overlaps which are also going to be taken from the adjacent parcels. So I don't know if you could focus on that. We need a report on those ones.
Yeah, you just want to annotate those just to how to show what those are. We're not really looking for misclosures on those. Is that correct?
Exactly.
Okay. All right. Sorry. I thought you were looking to find those misclosures, which is if that's what we're looking at here. So let's open another drawing that's in our data set. And this will be the one that I want. All right, this will give you a good example. Let's open a file called clearwateroaks.dwg. And we'll be able to talk about some parceling here at the same time. Okay. So if we wanted to label something, like what we have here. If I've now selected this perimeter polyline and I see, yes, it's closed. Okay, that's good. So there's not going to be any holes in it. I'm going to zoom in real tight down here to make sure that there's no little gaps. I think we're in good shape. That one looks like it's all the way to the edge. Same thing here, looks like it is all the way to the edge. So that should be okay. So what I want to do is I want to calculate the area that's all on the outside of these little center lines here, and then maybe this area in the interior, and maybe this area in the interior here as our first step. Okay. So if I go to my area layout menu and I choose my area by interior point. Okay, it says to pick a point inside the area. So if I pick this point in this middle here, it identifies that. It wants me to give it a lot description. I'll just take the default of 1. And it asks me to position it. So I'll put the label right here. And it's now asking me to pick another one. And when I'm done, I'm going to hit enter. So I'm going to now pick inside here, and I'll put that one, lot description of 2. I'll put it here. And I'm going to pick inside this area, which is all of this around here. And I'm going to call that remainder instead of 3. And I'll put it out here. Okay, so now that generated those layers based on me picking a point on the inside of those lists. Now, where those came from is here. The format of that label placement, the whole thing. If I go to my area layout menu and I look at my area defaults, okay, this is when I compute an area, what do I want to see when I place that label? And you can see all of the different things you've got available. I've got the coordinates of the centroid of that shape. I can look at square yards, square miles, square meters, cuerdas, square kilometers, hectares, geodetic square feet, meters, and acres, scaled squared feet, meters, and acres, et cetera, et cetera, et cetera, block name, perimeter, and user defined. Now, the ones that I chose were lot description, square feet, and acres. Those were originally in that list. And you can choose, if you double click that or select it and hit the edit button, you can tell it how to set these up. You can give it a text style, a text size, a layer, and color, et cetera, et cetera. That was for the description. For the square feet, same type of thing. I've got a suffix of space SF for square feet. And I'm using a precision of 0 on my square footage because I'm going to the nearest square foot. I'll explain this in just a second. If I look at my acreage, I've got the same thing. I've got a suffix of AC or acres, and I'm telling it that I've got this little plus minus symbol, and I'm going to make that a suffix after that acre label. And I'm using a precision value here of the number of acres as 4 decimal places. All right, now, what that means is this, is that, you know, I'm looking at this area is computed to the nearest square foot, but it's to the nearest 10,000th of an acre. And that's due to a mathematical or a numerical analysis perspective called least significant digit. And what it means is that if I'm looking at these two numbers, because there are 43,560 square feet in an acre, that's on the order of, I've got 43560. That's 5-digit places. That's ones, tens, hundreds, thousands, and 10,000. So it's on the order of 10,000 or 20, 30, 40, 50, blah, blah. That every time, if I were to change this number, 505537, if I make a change in the 1 foot place, it's going to guarantee that it's going to change this number of acres in the, not the 10th, the 100th, the 1000th, but the 10,000th decimal place because of that comparison relationship between the number of square feet in an acre. So a change in this digit will always trigger a change in this digit and vice versa. If I only computed and showed my acreage to the nearest 2 decimal places, this number here can change, you know, several, like maybe up into the hundreds before it would trigger a change in my acreage down here. So it's just a little mathematical rigor. It's nothing, you know, usually somebody's going to dictate how many decimal places they want to see. All right, so that now lets us create those particular areas. But we also have to looking at the parcels. So let's open this next drawing, which is this same Clearwater Oaks, but it's going to be called LotNet Final. And you'll recognize that same property, and it's got your subdivision lots, your house footprints, your setback lines, all of the labels, you know, the bearings and distances around each of the parcels, curve information. And for things that are too short, I've got line tables and curve tables. And I've got individual areas on each one of those parcels, starting here with, you know, there's parcel 30, there's 12. I did not renumber these. I don't, here's one. So I go 1 to 2 to 3 to 4. So all of these, and you see I've got most of them are set to 10,000 square feet. And that was automatically actually created for me. So it went all through there and labeled those again based on that same area default that I just showed you a minute ago. Nearest square foot, the nearest 10,000th of an acre. Okay. So if I were to take this and I have all of those little parcels, let's let me go to my view menu. And I'm going to say isolate layers. And the ones I'm going to isolate, I want to get the purple lot line, the outer boundary, and the right-of-way line around the roads, and say enter. So now I've got these as a bunch of parcels. Okay, now they're not necessarily closed figures. They do form a closed figure, but they're not drawn as closed figures. They're just lot lines, but they do connect everything up together. So how would I label all of those? And I would go to my area layouts, and if I did a, let's see, I want to do a, again, I would have to do it by interior point. I could set a table up to hold all my values. So if I do a layer and area by interior point, then as I pick these, and I'm just going to call that one 1. And of course, it's going to go to the same layer as those other ones. And so obviously they're going to match the same because these were all computed before. Okay. So then I just go through and pick each one of those individually and place them. Now, if I don't want to place them, let me get rid of, I'm going to erase those. So they're all gone. We'll start over again. So if I don't want to place each one of those as it happens, I go back to my area defaults again, and I'm going to change that. Do I use commas, use M-text? Label placement is center, rear side. That's all pretty good. Say, okay, table process, use area tables never. And area commands, maximum gap to join across, so I can compute these even if there's a gap. And prompt whether to retain polylines created by the areas of interior. That lets you actually generate a closed polyline on the interior of these shapes as well. So if I said to, let me look at my annotate defaults here for just a quick minute. I don't. Nothing there. Area. Just to calculate. Yeah, if I had these as closed polylines, that's where I could tell it to use multiple areas. But that's not going to let me do that by interior points. So let's do this. If I do have closed polylines, like you said you would have on occasion. So if I want to create closed polylines, I'll go ahead and make my color red. Well, I'm going to make a new layer here. So my new layer is going to be lot lines dash closed, I'll call it. I'll make it red, and I'll sit on that as my current layer. Now, if I draw a boundary polyline, I'm going to choose to put this on that lot lines closed, a 2D polyline, and let's choose all areas and see what we get. If we select all of these, there we go. So I've got that. I've got lot lines closed. And if I isolate now, I can see when I select that, it is a, oops, it says no. Those are all supposed to be closed. If I draw a boundary polyline by this snap tolerance 2D, it didn't close them. So I'm going to go to my edit menu and my polyline utilities, and I'm going to say close polylines. And I'm going to select all of these so that they are now closed. So now if I look at, say, this one, I see in my properties that yes, it is closed. So now that that is all a series of closed polylines, if I go to my area layout and choose area by closed polyline, I'll use multiple areas, and I could even total those together. I can get a, let's look at my formatted area report. I'll label the areas. Let's see if I don't do that. I will look at my auto place labels. And I'll say okay, and it wants me to select. So I just select them all, and now I'm going to take that same type of report, and I'm going to choose my square footage and my acreage, which is there it is. So acres. And I don't have parcel names in here because I'm just dealing with the geometry of the lines. So I'm going to make sure, oops, sorry, square feet go up. Now I want to edit that to be round to the nearest ones. And my acreage, I want to round here to that 4th decimal place. Okay, there's a heading, 7, okay. And now I can look at my display. These are all my reports, my square feet, my acreage. When I exit the report, it wants to know these lot descriptions. I didn't want. It's still stopping and asking me for those lot descriptions. I held the key down a little too far. This one then is this roadway area. This is the remainder out here, just in this little corner. Okay. So that way then took, and it started with 1 to 2 to 3, and it, notice what it did though, is it took these in the order of creation of those closed polylines. So 1 to 2 to 54 to 29 to 31 to 30 doesn't make a lot of sense for us. We would need some other tools to make those numbers.
Okay, Ken. Hello, Ken.
Yes.
Yeah. I think we have an understanding on this one now. Can we move to the report?
Yeah.
Report, because of our time. We want to move to the report, and then you would take us through the subdivision. So we really want to get to that side too.
Yeah, so that's where I'm really headed with all of this, is so that when we're back here that we're going to wind up with
Right.
yeah, so what am I looking for? So that we can get this and all of our lines and curves and annotation as well.
All right. All right then.
Is that what you're looking to do?
Yes. Yes.
Okay. So let's go back to this file. It's called Clearwater Oaks. It's the first of those two that I had you open. So let's go back to this one, and all that's in it is a closed outside boundary and some lines for the center line of a road net, of a collection of roads through my boundary. So if we look at that, that's going to be our ultimate thing, that we're going to take this entire subdivision and have it generate what you just saw before as an automatic generation. Now, there's a couple of other things too that you can do, or that some of the tools that you have, and I'm going to show you this real quickly, is I'm going to draw the real simple business like this. Maybe I'll add a vertex in here, and then maybe this okay. So this was what we're ultimately going to be working forward with this full subdivision, is called lot net. Okay. And that's, again, all of these things right here that you see, this lot network settings and such, and you've got some other individual little things that talk about lot files and creating lots and lot file manager and lot file utilities. This was sort of the front runner, the precursor to this lot network. Okay, so this is, but it's also very handy because you don't have to go through a whole lot of setup to do it. You're going to be able to just create a few as we're working there. So if we look at on our area layout, I'm going to set a lot file. I'm going to call it new, and I'm just going to call it simple dash subdivision, something like that. Okay, so all I've done was told it the name of the file. I haven't put anything in it yet. I'm going to now look at my create lots command, and you're going to be able to create these lots based on these different choices. You can design the lot, you can make a polyline into a lot file. You can create a lot file by picking interior, just like we did the labeling with the area labels. And then we can also do it by closed line work or by even interior text. So maybe you've got a map that somebody put together and it's got a bunch of labels in there. It says lot 1, lot 2, lot 3, but you haven't made a lot file, something that you can manage this with. Okay. So what I'm going to say is if I have a little area within, wherever I'm maybe working on a piece of property, I'm going to now actually close up these ends, and I'm going to make a little subdivision with this lot line. I'm going to, first of all, I need to join those all together so that I can close them. So I'm going to go to edit, and I'm going to join nearest. And I'm going to then draw a selection around that. I'll select that. I look at my properties, making sure it is a closed polygon. Okay. So the next thing I'm going to do is I want to create lots. And I want to create those by, let's design a lot. I need to give it a coordinate file. I'll call this one just lots. And there's lot 1, block 1, starting station might be, say, down here, and it's just a 0, and we'll call it point number 1. Oh, it's instead of that, I want to polyline to a lot file. Maybe, let's see, polyline. Not sure this is what I want to do. Created 8 lot points. Okay, so still not what I want to do. I want to have it automatically create lots. Let's see my lot file manager. Hmm. Yes, these intersections is what I'm looking for. So if I All right, so he's drawing the center line. Traversing 5 points. All right. Offsets. All right, so layout utilities. That's what I'm looking for is in these layout. There we go. I'm sorry. I thought they used to be all down here in lot manager. So if I go to my layout utilities, so pardon that little searching a bit. So if I go to my lot layout, for instance, okay, this is going to allow me to create some lots out of this little area here that I've got as well. So if I look at a target lot area in either square feet or acres, let's go with say 1/4 acre lots. So 0.25 acres will be the target size that I want to use. I want to have a minimum frontage of 50 feet. And what do I do with any remainder? Let's say I'm going to either spread that equally to all lots or add just to the last lot or make a separate individual lot that would be smaller at the end. So I'm going to just add to the last one. And this layer name, the lot lines, I think I put it, that's fine. And draw the lots as closed polylines or sidelines only. So if I say okay, it says select the front polyline. Well, this down here at the bottom of this little figure that I drew, that's going to be my frontage. And now it wants me to select the back. I think it's not, yeah, I've got to take these end pieces off. So I'm going to remove those segments. And I will trim this back down to individual. Okay, so now if I go to my area layout, my layout utilities, lot layout, I'm going to look at quarter acre lots, let's say a 50-foot frontage, a minimum on the back, let's say a 15-foot for a back, add to the last lot, close polyline. So here now is my frontage, and it wants me to select the back polyline, which will be back here. And that would be those individual lots, each one of which would be a quarter acre, or like 11,878.25 feet. So that would generate those as individual.
Ken,
Yes.
in your settings, right, the frontage, you said 50 and the back, but when the lots were created, I don't see the correlation between the figures that you chose.
Okay, so if I go back to this lot layout again, I'll come back to this now. Let's get these to be a little bigger than quarter acre. Let's make full 1 acre lots. So this minimum frontage, what it's going to do is it's going to start out here and go, it has to go at least 50 feet before it can create a lot. Okay. And then it's saying, okay, and in this case, from the frontage, it's going to go perpendicular to that frontage line until it hits this back line. Well, this back line is not parallel to it. So it's going to be, it's got to go at least 50, but then come into the 1 acre target. So it can tighten that down. And if we said that back line was 0, then it could make a single point in the back line. But if we do this again to maybe see this a little bigger, and then the back. So now there's my points. So this 50 feet is the minimum out here. Now this one happens to be bigger than 50 feet on this first lot. But because this back corner is closer to it, it needed to go more than 50 feet and draw this perpendicular line to the frontage to calculate that as an individual 1 acre lot. So if I now do my area by closed polylines, you can see that these were the original, I labeled them backwards because I selected them backwards. But the distance out here, and if I auto annotate above and below these, you can see this is larger than 50 feet. This is larger than 50, but that was my minimum. Okay. So if I said, let's use a, let's say we did a minimum of, let me get one that would trigger, let's say 100 and, say 100 and, let's say 165. So if I get rid of these and do that same layout, lot layout. And so now my minimum footage, I'm going to say, for my minimum frontage, I want to be 165. And let's maybe up that a little bit bigger here. I'll say, okay, here's my frontage. Here's my rear lot lines. And now if I do the auto annotate for this one. Oops. Now you see, I've got a minimum of 165 feet, whereas before we were underneath a couple of places. And our areas now are going to be one. Okay, so the target was 1 acre to go 165 feet. But for this lot, you see, it's a little larger than 1 acre because I forced it to go that 165 feet, but I've got more land back here to the back line. So it's going to create a 1.03 acre lot. Same thing here. There's more lines. So it's the first thing it's doing is trying to go perpendicular to the frontage. And here's a part of an arc. So it's going to go radial from that arc. Okay. So where we made it go at least 165 feet, there's just more land there than it needs to be. So there's slightly different ways, it had to come up with a slightly bigger area for that lot number 2 and lot number 3. Lot number 5 includes that remainder. Now, we can adjust this lot to be exactly 1 acre. And by a number of ways, we could take this edge over here and slide it parallel to itself until it makes 1 acre. But that's going to make my frontage smaller than 165 feet. But we could hold the point down here, this corner point at the frontage, and say, rotate that line until you make a lot that is exactly 1 acre. But then you're no longer perpendicular to the frontage. So there had to be a trade-off somewhere. That's the trade-off there's going to be. And so how you would do those particular adjustments is on your area layout menu, your adjust area. That's the last one I just talked about is a hinged area. The other one is called this sliding side. So if I choose a hinged area, and it wants me to define my area by points or by a closed polyline. Well, I'm going to use line work. So I'm going to take that lot number 2. And I said, select the polyline segment to adjust. Well, I'm going to choose this one. And it's going to be this first one, which was the first lot that it created. I select the hinge point is here. Keep the existing polyline. I'm going to say no. And what do I look for a target? Well, I'm going to say my target is going to be in acres. So I'm going to say A for acres. And now I'm going to say 1. Okay. And I took the wrong, I chose the wrong one. But all right. So let me put that one back and repeat my line work. I'll select this and it then will be the second one. Sorry about that. I got the wrong one. I'll choose that as an endpoint. Keep the existing no by acre. Enter the target area in acres 1. And it's still switching to the right. So there's that one, and then here is that one. That's the one it made. Let me take that particular line and change it to left. See it that way. Maybe we can make sure we get the right one. All right, so now, once again, area layout, adjust areas, a hinged area. I want to do by line work. I'll choose that line to change using that lot. Here's my hinge point. And I'll not keep the existing, and my target area in acres is 1. So there's what it did. It held that corner point and swung it over to this corner here. Okay. So that means now that, so that I don't have that little gap, I'm going to select this neighbor, and I'm going to take that corner and snap it over to that endpoint. But now I'll need to do the same thing here. I'm going to have to do a hinge point adjustment on that particular item, and I'm going to change that color to green again, so we can make sure that we have selected the right one when we are working with these. And so now I will go back to my adjust areas. I'm going to hinge that area. I'll pick the line, let's see, or choose line work rather, and then pick the line and make sure I choose that green polyline. I will select that endpoint. No need to keep the original. And I'm going to say 1 acre. All right, so you see what's happening is I keep adjusting these, and in which case you can see that I'm getting closer and closer, you know, smaller and smaller here. I really need to do something instead of using the right, so that's second. So
Is because
instead of enforcing that,
10.
yes.
Let me tell you. Oh,
So let's adjust that one with a sliding side. Again, choose by line work. I choose this one, choose, let's see, define the new line by the selected line. And for a target area of 1 acre. Okay, so now there's that one, and then this one would then need to be brought up to match. Okay. So with all of that done, then we need to, recompute our areas just to show you that we've done all of those. We will auto annotate the parcels themselves, and then we will area by closed polylines. And we'll say it's lot number 1 again. Of course, it's going in different different order based on what we selected here. So now we've got a full 1 acre, 1 acre, 1 acre, 1 acre, and then the 1.25 acre out here on the end, based on those adjustments that we made to those. Whereas the first bit of the constraint, when we said layout utilities, lot layout, we said use this as a minimum frontage. And here's my targeted area. So when it makes them from the frontage, it always goes perpendicular. So if I'm over here 165 feet and I go perpendicular, this one's also perpendicular, then wherever this back line is, that's why that lot wound up to be bigger than 1 acre, because the minimum frontage pushed it out bigger. But we adjusted it by swinging the line over, and we did another swing line adjustment, and then we did the slide line adjustment to bring that down here as well. Okay. So that is the individual bit of sort of some of these layouts. And you can choose those for just little small, small type of things, but you see the nature of what's happening with it as you go along. So what we're really after, though, is this lot network stuff. Okay, and so let's take a look at what that does for us really quick as a full-on subdivision design team. So I'm going to go to my settings menu, and I'm going to choose my toolbar setup command. And I'm going to come all the way down here to the L's, and I'm going to choose lot network. And I think that's all I need. Let's see. So I've got my lot network toolbar here. I'm going to bring it out here. And I've got some things. Now, the reason I'm bringing this out as a toolbar is because the order that we run through the process of LotNet is typically the same order that you see them from the menus. There's the lot network settings, and then you have to establish a boundary. You've got these, road center lines and all of these different types of things that you typically set. So we're going to start here with our lot network settings. That's the button on the left, or on the menu, lot network settings. So the first thing I'm going to do is I'm going to choose a lot network file to process. I'll make it new. I'm going to call this one just subdvn for subdivision. All right, clever name. I'm then going to choose a lot network. That's what I just told it right there. My lot network file is subdivision. I'm going to start with lot 1, my lot area tolerance. That's how closely these lines have to match. They're all going to be good. My edge direction, when I create the lots, is do I want to make those away from the frontage or toward the frontage? And like we saw that previous example, it went away from the frontage that set that perpendicularity. If we say toward the frontage, it's going to go to the back lot lines and go perpendicular to the back lines and go toward the roads. Okay. I'm going to tell it to automatically label my updates. I'm going to take basically all of my defaults I'll leave alone here, but here's what you would do is if these things aren't labeling the way you like them, the right layers, all that kind of stuff, you can set all of these and edit those features. Okay, so we're going to label the lines and arcs, label the areas, and that's basically it for what we are going to choose. Now, if we could output a lot file, that's an individual thing, but we're not going to need to worry about that because we have a lot network file. So I'll say okay. And I've now created that file, but nothing's happened. So all I did was set the settings up. So the next step is to choose the boundary. We're going to set the boundary. And we're just going to go over here and select that outermost boundary. Okay. All right. Still nothing looks like it's happened, but we're 2 steps along the way. And now we've got this road network business because that's what defines my subdivision is the outer boundaries and my roads in between that cut through them. But right now, all I've got are the center lines drawn. But that's no problem because my road network, when I choose that, is going to help me establish that. So I go to my new tab, and I'm just going to call this one subdivision RDS for it. So just the name of a road network file. And this little guy comes up over here on the side. All right. And it docks itself. And I'm back down to my command line prompt. I'm ready to go to the next thing. But the first thing I want to do is with this road network is to establish how these roads are going to be measured and defined in here. So I'm going to go to these icons at the top. I'm going to look at that gear, which is my settings. And I'm going to put in a bunch of default values. I've got my side intersections of 25 foot, and that is where, say, this road that intersects with this other road here, that's where the pavement radius, where those edges meet. I'm going to say a default of 25. Processing options, I'm going to say instead of recalculating every time something changes, ask me first before I commit to it. I'm going to also tell it to create lots. And this is where, just like we did before, that we had it automatically create those lots. Now, you don't have to do it here as part of road network, but you wind up having to do sort of piecemeal work with some of these other commands on the rest of the toolbar. But you can see what's going to happen when we say create lots. I'll go to my settings tab, and here's some of our settings. I'm targeting to have 10,000 square foot lots, and I want a minimum frontage of, say, 50 feet. And a minimum depth of 50 feet so that it's going to go from wherever the right of way is to the back line, making sure it's 50 feet. And a maximum depth of 200 feet. So anything beyond that, it's not going to create. And minimum back distance, again, I don't set a minimum for that because it can come into however it wants to go. And now my edge method. For my lot lines, I'm going to go perpendicular to the right of way or perpendicular to the back or at a specific angle. So I'm going to go from those road right of ways perpendicular to set this accordingly. All right. And now I'm going to say okay. And I've now established those settings, but I need to create the roads out of this line work. So I'm going to go to my red plus button, which is the add button. And I want to add a road, and it's either going to be by a centerline file or by a picked polyline. Well, I've got the line drawn, so I'm going to say pick that polyline. So I'm going to select it and assign a centerline file to that polyline. And I'm just going to call that one Main Street. And it says, warning, the center line is outside the area covered by the existing surface. We don't care about the existing surface right now. That's just a warning in case I were computing earthworks. I'm not doing surface modeling. I'm just going to do my layouts. Okay. So now I've got this main street. I've got a centerline file for it. I need to set in the right of ways. So my right of way offsets are going to be where I set this up. I'm going to make a new one and call that an ROW for subdivision. Okay, just a new file name. And I'm going to go over to the right now and choose edit. And I want to make this, I'll put them on the layer called right of way, and my left offset. Let's say if I want 50-foot roads, I'm going to go 25 to the left and 25 to the right. Any additional offsets you can add in here separately as well. I'll save and exit and say okay to that. So now it has identified that as a road called Main Street. I'm going to now create another one. Same deal. I'm going to make a road by screen picking the polyline. I will select this upper road now and assign a centerline file to that. And instead of Main Street, I might call that one, you know, Maple Street. Who knows? It's outside, no problem. We'll say okay. I'm now going to do one more. And notice what happens now that I've got this and this defined. Whoops. It computes an intersection. It recognizes that there is an intersection there. Okay. And you can edit those intersections and change radiuses. Oh no. Yeah, completely killed it. Well, much as I brag on how stable it is, yeah, off it went. Come on, come on, come on. Last session was not closed properly and there are no files to recover. How lovely for you, AutoCAD. Thanks for doing that to me. Okay. So I'm going to bring back my lot network toolbar. Set up my settings. There's my lot file. And I've got starting one lot edge. Those are all good. My boundary. It's my outside boundary. My road net. Do a save as. I'll just call it subdivision roads. Okay, let's look at my settings now. 25 prompt, 5, create lots, make my settings. There's my 10,000 square foot, 50 minimums, 50 depths, perpendicular, add to the back. That should be good to go. Say okay. And now I'm going to add a road. I'm going to choose Main Street. My right-of-way offsets were these. I'll make sure they are still set. Yes, they are. So this is one of the reasons that it's really nice that Carlson saves those things as we go along in those external files, because they're still there for us, even though the file died on me. So I'm going to now do another one from the center line. And I've also got that intersection like I told you about before, but let's add the third road now, which is from a screen pick polyline, which is this cross street. I'm going to assign a centerline file to it, so I'll call it cross street. Clever boy that I am. And it's there now, and I now have 3 roads. I've got Cross Street, Maple, Cross, and Main, and I've got intersections, Main Street to the end of Maple Street, Main Street at the start of Cross Street, Maple Street at the end of Cross Street. And I do want to go to one last bit, and I want to add a cul-de-sac on the end of Main Street. So I'm going to put that in standard. Again, you can set a lot of these things to your liking. I'm going to make my cul-de-sac right-of-way radius to be 80 feet. And my fillet right-of-way radius, again, I'll make it 25 feet. No offsets, and that should work. And there's where that is, and you've got some things there. I will now save this RoadNet file, but remember we told it to create lots and do all of those things. Well, now that we've got everything loaded up, we've got a boundary, we've got all our streets, I'm going to choose this button here, lower, or the lower row of buttons on the left that says process. So when I choose that, it's going to compute the right-of-way. And you can see all this stuff happening behind it in the background. And it's now going to go through and generate lots. And it looks like it stopped and hung, but what it's asking me for on the command line, it wants to know the starting point of a curve table. Well, I'm going to go over here and give it a starting point for the curve table, and it wants to know a starting point for the line table. I'll pick it over here. And so it's doing that so it knows where to start drawing those curves, the curve and line entities in our table. Okay, so there's our line table. There's our curve table. And there now are all of our parcels. We're showing our setback lines. We've got our setback limits, and I've got this kind of goofy looking parcel in here, so we can make some changes to some of that. And you've got a bunch of little things in here that I can look at this particular set of lines that it made, these little short chunky pieces of lines. We could, straighten those things out individually if we wanted. But one of the things that we can fix here, instead of this weird looking lot, is, let's see, let's go from a minimum. I'm going to come back to my, let's see.
Yeah.
Yes.
If I had topo data on the lot, will it make the subdivision different, or it will be just the same thing?
When you say you have topo data, you mean you've got the actual
Well,
corner?
And then I have a model for the lot itself, the terrain model for it.
Oh, okay. So you got a terrain model for your property here?
Yeah, and I wanted to do a subdivision the way you've done it. Will it affect the areas, or it will be the same thing?
No, the areas are all exactly the same because they're horizontal planar areas. Okay, so it doesn't matter how that goes up and down. However, there is something that's really helpful with that. The fact if you do have a if you do have a topographic, if you do have the elevation information, is when we do our settings, where we say create lots and look at my settings, let's see, let me change this to minimum frontage, minimum depth, maximum depth, minimum back distance. I'm going to also say 50 feet. All right, so I'll let that network. And then if I edit just one of my streets, let me see what. So what I wanted to look at, I wanted to look at the right away. Yeah, so in this particular road network, because I'm doing it through my lot net, then it's going to always do that. Let me just go ahead and reprocess because I changed this back distance from 0. I gave it a minimum. So anyway, this is going to create this as 2D layouts in my exit that a minute ago. Here, let's go back to that. Why is it not Main Street profile? It's looking for, oh, it's looking for profiles. So I don't have profiles in here yet, but all right. So if I'm letting it recompute those. So again, having the elevation information for these lots doesn't do anything for me in terms of the areas. It's still going to lay those things out separately. But here's what I wanted to show you is that once this is done as a separate thing in this regard, this is through the survey module using using LotNet. You can see I really screwed up that corner in there. So anyway, and we can make some changes. All of these little changes up here, these little buttons are just like we did those changes on that little sample of about 5 lots where we can add and some, remove and do different things with different lots. If we, let's see, move a lot edge point, I'm going to say I'm going to move this point, pick the point on the polyline to edit that point, and I'm going to put it right down here. And then I'm going to do the same thing. I'm going to take this one and I'm going to put it, let's say, perpendicular to here. Didn't work. Let's see. Take this one, and we'll put it here. Ah. This one. There we go. That's more what I meant to do. And then if we have this, I want to take that one and put it here. And so now once I've made those changes, you're going to see it's going to go through and recompute, redraw. It's asking me to check my label overlaps. So, I can do all this stuff in my 2-dimensional layout space, and it doesn't affect that at all with those elevation information. But where this does come into play is if you have the civil module, and I'm going to switch to the civil module real quick. And I'm going to go to my roads menu and choose my road network from here. And it's going to load this same thing up, but it's much more extensive. You see, it's got design profiles, cross-sectional templates, all of these different types of things. And if I look at the settings here, like I did in LotNet, that's just using my horizontal stuff, if I look at my, let's see, my output options, triangulate and tour. There is a. Sometimes triangulate. Yeah, so you give it a target surface so it can calculate volumes. But what I'm trying to, let's see, since slopes output file. Oh, I'm sorry, it's right here. Elevate the pads and elevate the lots. Okay. So if I have building pads, I'm going to say, okay, I'm going to use my setup. I'm going to say for those building pads, I'm going to give it a particular, layers and offsets and certain things like that. And I'm going to say, where do I want to choose the reference elevation of the road? So if I've got this road that has a designed profile, so I've got elevation information along the design portion of those roads, I can say as that lot is being created, as you walk along that road center line, take either the lowest elevation, the elevation in the middle, or the highest elevation, or some other reference point to set the reference elevation. And then it's going to go up at a targeted 1% slope, but I'm going to have a minimum of 0.5%, a maximum of 1.5%. Those can be any numbers you want. And then and that's for cut, and I've got the same thing for fill. And I can then create these. It's going to generate these lot lines now are going to be in 3 dimensions. They're going to be 3D break lines for me. As if I will, and I can also keep them as, see this assign new layer, elevated pads layer. So that's where the break lines are going to go, but I can retain the original polyline to keep those as 2D lines if I wanted. All right, so that sets up the pads. I can elevate the lots the same kind of way. I'm going to elevate the lots based on a grade rules. And if I choose those, again, I can set my, how do I want to do it, by percent. My normal for the front slope, and this is if I'm in cut conditions on the left, if I'm in fill conditions on the right. So I'm going to say, take those lot lines. Now, the last one we were looking at, those shallower ones were building pads. These are the actual lot lines between the building pads. I'm going to say, I'm going to go up, I'm going to target at 2%. I want a minimum of 1% and a maximum of 10%. And then I've got the back half down here below, and I've also got some intervening things here in the middle. I think if we look at that, if I can find it, let's see, road network, it's maybe not there. It might be here where we elevate lot edges by grade rules. Here we go. So this is where that's coming into play. So here's a subdivision up here, and we've got a, say a back of a sidewalk, a road center line, the edge of a lot, and the setback line on there. Well, we can then, as you can see in this, the image down here below at the base, you can see how it actually raised up those lot lines. The fronts, the sides, and the back lot lines were raised up based on the elevation of the road as that road changes. And the nice thing about that is when that road may change, and you may have, you may simply make a design change on your road and when that road goes up and down, it's going to bring all of those lot lines and intersecting roads and everything else with it as it makes those changes. When you're telling it to drive all of this stuff, this elevation for you. Now, you said you already have the elevation information for those lots. That's the existing ground, what's out there now. What we're talking about, what I've just was showing you here is we're talking about are the actual design elevations. And so when you have the existing elevations, now you're going to be able to go into your surface menus and choose to compute volumes between two surfaces. I've got an existing ground and I've elevated all of this design information into a proposed ground surface. And now I can use my earthwork computations. I can get volumes. I can do cut and fill analysis. You know, just going to help me to establish that design. But in terms of the lot areas, though, those are always planar, they're always level, they're always horizontal. Okay, so that's not going to make any effect with that. Okay.
Ken,
Yes.
yeah, Ken, is there a way you could extract all the points? Let's say you want to stake them out, or you have to do it one by one?
No. We can do that. Let's do that real quick. And that instead of having this mess, let me close this drawing and I'm going to have you open up this other one that we just had a minute ago. Let's open the what did it said? LotNet final, I think it was. So we'll go ahead and open that up. I still got my road network. Okay, it cleared it out. All right, and I'm going to close this. I don't need that anymore. All right, so if I want to stake out all of those lot corners, right? Now keep in mind, I've got some here that are really, you know, I would take some of these things out, all right, but I'm not going to take the time to do that part right now. So the easiest way to do this is by creating some points that we're going to stake out. I'm going to stake out all of the property corners. Now, again, you could drop one on each corner individually, like you said, but hopefully we don't have to do that, and we don't. So just to make it easy to illustrate and to pick, I'm going to isolate those lot lines. Okay, so I'm going to go to View, Isolate Layers. I'm just going to pick one of those lot lines. So there now are all of the points that I may need to, oh, let me do one more thing. I'm going to restore. I'll isolate the lot lines and the boundary. There we go. So all of those things are the corners that I have to put monuments in for. You know, these, like this large lot that was originally down here, that's one single arc that it goes between, say, where that point is and that point is. That's all I really need. And I can, you know, if I needed to stake out the roadway, I could leave that right-of-way line sitting there as well. Okay. So how do we get these points on here? Well, I'm going to go to my points menu. I'm going to set my coordinate file. And I'll make a new file, and I'm going to just call it stakeout. Okay. Now, instead of having to draw locate points and put them on all of these different snap to endpoints, et cetera, if you go to the core, go to your Kogo menu, right here it says create points from entities. And I can do that. I'll go ahead and draw the points while I'm at it. Give it a symbol. I'll put it on a layer name called stake points. And I'm not going to label any elevations at this point. There won't be any. And same description. I'll just call it COR for corner. I will say, okay. Now, what things do I want to process? All of this line work. For curves, I'm going to skip the radius points and the midpoints. And I'll draw the new points. I'll say, okay. I'll now select all of my data. And there now are all of those points, including all those little short ones, okay? So now to make those into, to stake those out then, is you can do a radial stakeout based on, an occupied point, a backside point, and which points you want to stake out. You can do them all, select them from the screen or give it a list. Say, okay. And these are going to have, the 4 sites are going to be too long, but there's basically your stakeout. It tells you if you're sitting at 1, backsliding 2, you need to turn this angle and go that distance to reach each of those points. Okay. Did that help?
Yes, Ken, it's okay. Thank you.
Okay. I mean, did that answer your question?
Yes, it did. Thanks.
Absolutely. So, anyway, we did not actually get around to the,
Ken,
yes.
before you disappear, just one last question.
Okay.
Oh, there's a couple of them, but from me, I don't know, I was not here, but I don't know whether you touched on the online checks. 2 beacons which are known, then you're establishing a new point in
Yes.
between.
Yes. Very good. And that's a pretty simple thing to check. I did not touch it yet. But
Okay.
that's the checking for collinearity.
Yes.
If we go up to, I'm just going to go off to the side here. I'm just going to draw.
Also,
Hey.
if possible, maybe we see the report itself.
Yes. So if I've got a line here and I'm going to copy that, I'm going to put it like right beside it here. And I'll show you what I'm going to do with this to illustrate it. So I'm going to make that one red. And I'm going to choose to add a polyline vertex. I'm going to choose this polyline. And now I'm just going to start picking a bunch of points. Okay. And some I'll do right on the line. And then maybe a couple of more and be done with that. I'll now put these, let's put these points here. All right, so this is going to be some points. I'm going to say the same thing, entities, or create points from entities. Let's create alignment points. And we'll say, okay. All right, so there I've got a bunch of points, 183, 84, 85, 86, 87, that sort of stuff. I can even get rid of this. But this is, I've got 183 to 193. I want to see about whether these other points are on that line or how far off they are, correct? So,
Yes.
yeah, so if we go to our coordinate geometry, well, before I do that one, let's look first at the center line one. And if we calculate offsets, so that center line is going to be that alignment. Now it can be a straight line or it can even be a full-on alignment with curves and PIs and all that stuff in it. But we'll take it as it is intended here with just the single line. So I'm going to go up here to the top and I'm going to define my center line by a, let's just call it a 2D polyline. Okay, and we'll be picking that. So I'm going to say, okay. And I'm going to select that. And now as I go through here, I can, let's make sure I've got it on. All right, so you see it's putting my station and my offset is computing what those points are. Okay, that's individually, I'm picking it. It's saying at station 2 plus 66, so 266.724 feet along this line, 33.42 feet off. That's where that came from. Okay, so, and there's my report that comes from there as well. Now that was where I picked things individually, but we can do that sort of as a block. And if I don't know if I can do it here. Let's see if I report the, I don't want to label them. I'll just report them left and right. So I can't, yeah. So with this one, define the center line by. So there's my center line. Now pick a point or point numbers. Now right now is because I picked those individually, but if I look at my choices, I can take S for selection set. So I want to actually look at all of these points by selecting them and hit enter. And now I'll hit enter to finish so that it gives me a report. Do I want to use another alignment? No, I'm done. So now I've got those points at that distance and that offset. And you notice these three right here are the ones that I snapped right onto that alignment. Okay. So now another option instead of that, as far as how far on or off a given alignment is if you go to the COGO menu and do a best fit, and we're going to do a best fit center line or line by average or line by least squares. So if I do a center line, I'm going to input my existing data from points or a polyline. I'm going to say from points. It says select the points from the screen or by number. I'm going to say by screen, and I'm going to now select these points. Now, if I choose to try to fit this as a center line, you notice this radius value. So if I had a bunch of points that sort of were surveyed, in fact, let's do that real quick. If I opened this file that you gave me the other day, and I noticed that, you know, I've drawn a bunch of these points. So 12, 14, 27, 25. So I've got 4, 11, 24, 23, 22. All right. So they're not really all in order, but all of those points could lie along a potential center line. Right now, they're sort of shot in the center line, but they're not mathematically rigorous, let's say. So if I did a best fit center line, and I'll choose this time by a line, I'm going to tell it to make my curves tangential, and I'm going to give a maximum radius of, let's just say 1,000 feet, I think would be all I need there, and a minimum point for an arc. let's say 4, we'll say okay, and I'm going to now pick that point. And now, this is each of those points that lay along that line. That's what you're seeing here. It computes the residuals. And it does a best fit. Now, if you've got one, let's say there's one of them that shows to be really big, like this 0.622. And if I were to say that I didn't want to include that one, maybe I concluded from that distance that it's too big, I could simply remove that point from that alignment. So I'm going to remove that. I can use report. I can see, I don't need that. I'm just going to look at my residuals, and there they happen to be. The points aren't numbered because I picked them from a line. I'll say okay. And so it was trying to define a best fit center line. Again, let's see if I can do that again. Move outliers. All right, it's just giving me that report. I'm trying to get it to let's do points. And let's say screen. So what this does is when I've got these points, and see here's one that's off, and see how that put that smooth curve through there. Okay, maybe that's what it did, draw it for me. Okay. Let me look at that. Yeah, so what it did, it actually did what I was wanting to do, is it went through and modified that line into an alignment. You see, it's got a tangent piece, it's got an arc, it's got a tangent, an arc, a tangent, and et cetera, et cetera. And I could even, if I double click that, give it a name. Best fit. Now, if I look at that as an alignment, you can see those individual pieces. And there's a curve. So when it analyzed all of those points, it went through and it created this as a true tangent-based alignment through all those points. And it did not exactly go through each of the points, but it created the figure that would be the best fit through those points. Okay. Now we've got another one. I'll switch back to our other set of points here. We've got another similar thing if we do a best fit line by average. So I'm going to pick a point or a point number as my starting point. So there's my point 183. Selecting the points by screen or group or number by screen. I'm going to say select all of these points. And there now is that same type of this, and we've got a particular residual off of a single line that goes through there. Okay, because as you can see, it goes from the start to the stop, and all of those little residuals that you just saw oops, let me see if I can just display the last report. So there's the last report. So 184 was 33.36 feet off the line. 185 was negative 29 points. So it's to the left, 2961. That was very much like our compute station and offset command. Okay, and you should see there we've got those that are sort of zero, but they're not exactly zero. It did compute the average, and the reason it wasn't exactly zero was because it computed the average instead of computing going from 183 to 193. It's off a little bit there. That's why these points that were originally on have a little bit of residual, and those are these three right here. Okay, so that's why they are showing up as not zero, but close to. Now, the other option, very similar to that, is this best fit line by least squares. And you can select a point from the screen, and I'm going to pick the line work. So I say from the screen, and I'm just going to select all of these and create a 2D line. And I can, if I say don't hold anything, draw the line, I'll say okay. Here now, again, it's going to give me those residuals, and I can choose to include them or not. I'm just going to say okay. There's my report. You see those similar type residuals. I'm going to exit that. And now notice it doesn't start at the same starting point, nor does it end at the same starting point, but that is the best fit line with the least amount of residuals going through all of those points. Now, to do that as an alternate way, again, by screen, I'll take these points, 2D, and now this time I'm going to hold a point, and I want to hold point number 183. And I can give it a statistical weight that I want to assign to holding that. So I'll say okay, I'll say okay, there's my report. And now you see it's a little bit closer, but it didn't hold it exactly right. It's still trying to minimize the least squares, but we just doubled the weighting, the weighting, W-E-I-G-H-T-ing. Again, let's do those points. Or you could hold a bearing if you knew what that bearing was, and you could do that same particular thing. Okay. If I do hold a point, let's put the weighting up to be 25. So we're going to really weight it heavily. Error, couldn't find your point. Let's try that again. By screen.
Can I hold 2 points?
Can you hold 2 points? Not with this particular one.
Okay.
But if you, let me set that back. You couldn't find it. I need to keep that weight down apparently here. I can't do it with that particular one. What is?
You selected 2 for the weight.
Yeah, but which is okay. Hold the point. Oh, it wasn't that. I'm going to put this back up to 25, but I need to give it a point number. That's what I neglected to do. That's why I couldn't find the point. And so now we go. And now there's that. And now you can see I've got even closer than the 1 or 2 weighting. So it doesn't force it to that, but I can do that if I do 183 to 193. Okay, so that now goes exactly through both of those 2 points, and I want to check to see, I've got 3 that are good on the line, these others are bad. And so now you could do that either through Centerline, where you're going to calculate the offsets, or under Koga, your best fit line, and you're going to do a best fit. So you do a best fit center line, and we're going to input our existing data from points. Select the point from the screen. And if I want to look at these, but not those 2 on the end. No, see, that's going to actually try to create it as an alignment. So I guess the best one to do to check that, to be able to hold those 2 endpoints, is this center line, calculate offsets. And we will get 2D, so we go to there. So here's now the defined alignment, and I'm going to use selection set for these points to check. So I'm going to get everything but the endpoints, and I can still snap and see, you see this little floating box that tells you, but I'm going to say enter to end, use another alignment. I'll say no, and now here comes my report. And here's where those 3 points here in the middle, you see with the offset of 0, those are the ones that are right on it. And all of those other points, then it calculates how far off and how far down the length of it and how far off those points are. Okay?
Yeah. Okay, thanks.
You bet. Any other things we can talk about? Let me tell you, we don't really have time to go over this the plotting business with getting this on the paper into scale. And again, it's sort of really more of a CAD function, but there is a something I'll point you to. And if you look in the help system, and let's look at the Carlson manual. I think it's under this tutorials. Is if I open this up, let me see what I may have. Cut sheets. It's really more of a yeah, it's really more of this CAD basics. Let me see if that tells us about. No, I thought there was something in there. So I would then suggest that you go to your help system and go to the online training movies. And then when you're here at their YouTube channel, look for, well, let's look for paper space. Paper space. And this will show you, and this will even go outside of Carlson's. It shows you AutoCAD, model space, paper space, and printing. And that's probably a little nice little thing to show you how to set those up. It tells you about viewports. Here's another one, viewports down here. Everybody, Brandon, blah, blah, blah. And that's, some of those are not Carlson. They're just CAD in general. So that's going to help you understand how that part's done. And if we had, another day or two, we could certainly run through that. And but
Or you can do this, Ken. You can maybe send us the most suitable tutorials to look at, maybe as a link in
okay,
an email.
I can
As
do
you
that.
also send us the recording for the sessions.
Yep, I'll do that. Send links for good layout printing. There we go. Good idea. I'll add those to what we send out with the certificates, and everybody's going to get an extra hour for any continuing education credit. I don't know if any of you have to do that or not. We do in the States, to keep our registration. Like, I'm a professional engineer, so to keep that, I have to have so many per year of continuing education units. So you get for credit for all 3 days of 6.5 hours each day, plus you get an extra hour for today because we ran over. So I'll get everybody their certificates, and along with that will be links to the videos, as well as links for these tutorials that might be good to watch. And I'll research that a little bit to get you the better ones. And we'll go from there. Now, when I send you these links for the recorded sessions, normally when we send those out to a classroom full of people that just sign up in what's called a public class, the only people who get those links are the people that are physically in the class, because they're the ones that actually paid to attend the class as a student. Now, this is different for you folks because you are under what's called a custom training, where we said, we're going to train the entire department, all of you folks, no matter how many people you want in the classes. And it's not on a per person basis. It's just a flat rate for each day. Okay.
Yeah.
And the advantage to that is you're going to get these links, and you're going to be able to share them with anybody and everybody you want to down there that might not have been able to attend the training, but maybe that might be helpful in illustrating a particular point, as you're trying to bring other people up to speed. So I do encourage you to do that, to share that, to pass that along, because that's just one of the advantages that you get for choosing to have your training done as just you folks, just Cayman Islands government, and not, I'm going to send these 3 people to class and they're each going to pay their way. And then there's going to be 5 people from, Paducah, Kentucky, that showed up in the class, and 2 from, Chicago, and 1 from it's not any of that stuff. So you don't have to worry about compartmentalizing any of that. This is all your stuff, all for you. So please do share those along with everything else. I will only be able to issue the certificates to that list of people, I think, James, that you sent me, 2 sessions ago.
Yes.
So I'll make all of those out individually, and that will be whether you need to have the credit based on your registrations, or whether you just simply, want to have a nice
Do the
little.
credits work with the rigs?
Say again?
Do your credits work with rigs?
I'm not following. Do the credits work with what?
Royal Institute of Chartered Surveyors?
Mm-hmm.
Do the credits that you'll give us, can we use them there? As our CPDs?
I don't know where you're asking to use them. Will they work with what?
RICS.
Yes.
Okay, like
Ken,
I said, yes.
do you know the body Royal Institute of Chartered Surveyors, RICS?
Oh, okay. Thank you. RICS. I wondered, because you're under the British system, right? So that you're
Yes.
with chartered surveyors.
Yeah.
They should, if they are enough, if they do not require you to get pre-approval, like everybody in the States does not. You simply go out and get it, and you have to keep records of it, and you have to document that you attended the training based on, and they can then look at it and evaluate what you did and decide whether or not they're going to give you credit for it after the fact. Now, we do, though, because years ago, we used to belong, we had certification from a group called the International, what was it called? It was called IACET, the International Association for Continuing Education and Training, and they certified all of our materials. We went through a pretty lengthy approval process to get that certified and bounded. But then all of the state registration boards in the US decided not to recognize that anymore. And they said, well, we're not going to need any credit for that. So we dropped all of that. So it meets all of those international standards, or did for a while back. So if you are a chartered surveyor, then that should certainly apply for you.
Okay, Ken, you can send us the credits as well.
Oh, yes, I certainly will do that with the certificates. Now, I want to, let me go back and find. I was just going to verify. I don't see the. Yeah, let's see the original. Let's see, James. So, here it is, yeah. So I've got James and Jerry and Godfrey and Orville and all these people. Now, are any of those folks, are they chartered survey? Like, do you have, like in the States, we might say LPS for license, or PLS for like professional land surveyor? Do you have any of those kind of initials that you want on your name, or just put your name on these certificates?
Just put the names. I don't think.
Okay. Yeah, so like you wouldn't have to have that. Like when I attend a continuing education for mine, if I were to do that, like it doesn't matter the fact that I am a PE, I don't have to have that on my certificate, but I didn't know what your government might require. So okay, so that'll be good. So everyone, these folks will get those certificates. You'll get the links. You get the links to the training. And again, you know, you've got my contact information. So get back in touch with any other questions as you go along. Okay.
Okay, Ken, thanks.
Absolutely, gentlemen. Do enjoy the rest of the week, and we'll talk soon.
Yeah,
Okay, thank you.
we'll see you for our next class.
Your next class? Whenever Darren, the boss, yeah, whenever whoever the director is says they want to hire some more training, we've got the 3 days that we've contracted for. But if you'd like to do any further training, we certainly can do that. Just
Yes, Ken.
Yes.
So we'll contact you individually, not from the government, individually. If you need anything, we'll contact you individually for any possible class.
Yes. Okay. Wonderful.
Take them all a number.
Okay. So
Jerry, anything from your end before we close?
everybody good? Think of anything?
That's it for now. I mean, more exploring it, but thanks for everything.
Absolutely. Well, you guys, I don't know what's your local beer there in the Caymans. It's not, I know like Red Stripe is up in the Bahamas maybe or something. And there's Calic beer or something in Jamaica. I don't remember the name, but do you all have a local beer that you have that everybody likes? No? Okay. No worries. Well, if you had one, go out and grab a cold one and enjoy it. And we will pass this information along as we get it. It'll probably be the first of next week before we get it to you. But then we'll go from there. Okay, doke.